Hi students, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher, and belated Merry Christmas to everybody and incoming Happy New Year to everyone. And I pray that you will wait a minute, just a second. My mistake. Let me just cross it. Okay, so on this new year, that is 2025, I just pray that you get everything that you want and everything that you are preparing for, everything that you are hardworking, you're putting your hard work for, right? So may God bless all of you, and may this next year brings a lot of positivity in your life, and the next new year, the next Christmas, you celebrate in your dream college with your buddies. Okay, so yes, everybody, today this is day 5 of organic chemistry. Till now we have completed GOC, isomerism, then we have completed naming reactions. After that we also did important reagents. Today we are going to do flowcharts. So it's not going to be a very lengthy lecture. Very few questions I have picked up, very selected questions. And guys, these flowcharts, so you are totally going to love. Do you want to see? Do you want to just have a look at those flowcharts? Then I'll just show you that. Just give me a second. So this is number 1 flowchart. Then, answer. Number 2 flowchart, right? Then you have, wait a minute, number 3 flowchart, right? And then you have number 4 flowchart. Then you have number 5, right? This number 5 flowchart is really big, right? Then number 6 flowchart, number 7, number 8. So totally we are going to do 8 flowcharts today. Okay, so I'll be starting with very simple flowcharts, and after that we'll continue with the complex flowcharts. So basically the one that I showed you here, right? These flowcharts, these are basically a little bit complex flowcharts, right? They involve some reactions that are quite tricky, right? So we will do these 3 flowcharts in the end. Firstly, we will do some simple flowcharts so that you can have in your mind that you will be able to recall everything in your mind. So basically, basic to advanced level we are going to go, right? Okay, so is everybody ready for this? I'm going to give you 2 flowcharts for your homework, and that also you should do, right? Everybody, if you are ready, previous year question, you will see, if I talk about this particular section now, here you will see around 40-50 previous year question in this flowchart only. Like they will pick this section, they will pick this section, they will pick this section and give you the questions. Right? That is why I told you that try to understand with the help of these flowcharts, so that in one single flowchart you are able to do 40-50 questions just like that. Right? So it is very time saving. You can save your time and you will be able to answer a lot of questions, and it's like a brain practice, right? It's like a brain practice. It's like solving a puzzle, right? Okay, so let us start the session without wasting any time. And here I have a very simple, firstly I'll just pick up a very simple flow chart with you. It's basically not a flow chart. Firstly, I am not picking any flow chart. Firstly, I am picking a simple reaction. Okay, simple reaction I am picking, right? It's not basically from A to B, B to C. It's like from this, you can have these many compounds, right? So this is the most simplest chart that I have for you today, right? Now, I want all of you to answer this, right? I want you to be very active in the chat box, right? Okay. My voice is not in sync, is it? Wait a minute. Let me just see why it is not in sync. Putting so much effort. Most welcome, beta. Most welcome. Just give me a second. Give me a second. Hello. Hello. Let me see if now I just took a biggest risk. Now it's fine. Now is it fine? Guys, let me know in the comment section if I am visible to you or not. Yeah, I think it's fine now, right? Okay, I just took a risk here. Okay, yes. Now, let us start with the first question here. First chart here. I'll just give some names here. Let it be, this is A, this is B, this is C, this is D, this is E, this is F, G, H. Okay. Now you have to tell me what is this A, B, C, D, E, F, G, H. Okay, bacha. So you have to tell me what is this A, B, C, D, E, F, G, H. So firstly, talking about what is A. Okay. So here you have also this one. H, here also you have I. Right? I, J. Where reagents are missing. Right? So first thing, everybody in the comment section. First is they are saying that from phenol you have the formation of ortho-para substituted product, right? Ortho and para substituted product. So here beta, as you can see that what we can observe here, ortho and para, right? Ortho and para substituted it is, right? So ortho and para substitution, right? This is the reagent will be. Basically, we are doing the Friedel-Crafts acylation here. Friedel-Crafts alkylation here. So, reagent will be, here reagent will be CH3Cl anhydrous AlCl3. That is going to be the reagent that we are doing Friedel-Crafts alkylation here. Second is, from phenol, we are adding Br2 in presence of a non-polar solvent, that is CS2. That means, here tell me which product will be formed. Which product? Here what we are doing, we are adding Br2 aqueous. Here we are adding Br2 CS2. Yes, very good. When you are adding with CS2, that means non-polar solvent, you will have the formation of ortho and para product, right? Ortho and para product individually, where para being the major. Para will always be the major product. But if you talk about Br2 aqueous, then what you're going to have? You are going to have a phenol, right, substitution, but both at ortho and para position at the same time. So it will be Br over here also, over here also, over here also. So that will be the answer. Okay. Now everybody, what will be the answer for C? What will be the answer for C? Everybody in the comment section, what will be the answer for C? That is dilute HNO3. And here I have added concentrated HNO3. Answer for C and G. Answer for C and G. If you talk about C and G here, C is dilute HNO3. Dilute HNO3 and this is concentrated HNO3. Right? Concentrated HNO3, you will have tri-nitro product, right? Okay. And if you talk about dilute HNO3, here you will have ortho and para product, ortho para nitrophenol for C. Very good. Here you will have ortho and para product. Now anybody in the comment section, which will be the major product? Which is going to be the major product? I told you always para is going to be the major product. But if you have anywhere you have seen hydrogen bonding, in that case, only in that case, ortho will be the major product. Only in that case, ortho is going to be the major product. Very good. Now, next is let us do, okay, tell me about what is this reagent J. What is this reagent J? Everybody in the comment section, what is this reagent J? Here it is phenol and you have added some J and here you are getting substitution at ortho and para position and the substitution is of SO3H. That means we are doing the sulfonation here. So what is going to be the reagent? Everybody, what is going to be the J reagent? J is going to be very good. J is going to be oleum or you can say H2SO4 in presence of SO3. That will also form oleum eventually, right? Okay. What about B? Okay, everybody, what about B? If you are adding to phenol, you are adding Na2Cr2O7. That means you are oxidizing it. Now, which thing will be formed? Everybody, what will be the answer for B? What will be the answer for B? Na2CrO3, we are basically oxidizing it. Then which thing will be formed? Anybody? Yes. So answer will be double bond over here, double bond over here, double bond. And wait a minute, let me draw it again. Let me just draw it again. It is going to be, here you will have double bond, double bond, double bond, and a double bond over here. And that is going to be the very good benzoquinone, or you can say hydroquinone, is going to be the correct answer here. Very good. Okay. What about D? What about D? And what about E? Also, these are the two very, very important naming reactions. You have to tell me what are these naming reactions. Okay, what are these two naming reactions? D and E. What is this D and E? If you talk about CCl4NaOH, CCl4NaOH, and this is okay, wait a minute, let us do one thing. This should be CH. Acha. Three things, beta, very, very important. Three things we have. You have to tell me D, E, and F. D, E, and F. Okay. Now, very good. This is Reamer-Teamer reaction. This is also Reamer-Teamer reaction. When in Reamer-Teamer reaction, this is Reamer-Teamer reaction. This is also Reamer-Teamer reaction. When in Reamer-Teamer reaction, you have CHCl3. In that case, you will have the formation of salicylic aldehyde. But in the Reamer-Teamer reaction, if you have CCl4, in that case, you will have the answer will be salicylic acid. The answer will be salicylic acid. But what is this E? What is this E and what are these reagents? NaOH, CO2H positive. What is this called? Everybody in the comment section, what is this called? Everybody, yes, you are right. You are writing it correct. Yes, everybody. What will be the answer? Answer is going to be very good. Salicylic acid. Shabash. Answer is going to be again salicylic acid. And what is the name of this reaction? Name of this reaction is Kolbe's reaction. Very good. Name of this reaction is Kolbe's reaction. So this was a very simple chart that I showed you, right? And in this way, you can remember all the reaction in just one go. Okay, perfect. Chalo. Now, let us do one more chart here. Let it be this chart, okay? That we are doing here, this chart. So, in this chart, what they are asking us, they are saying that you have some benzene. Now, firstly, tell me, if you want to convert benzene to phenol, what you should add? If you want to convert benzene to phenol, you are adding, no. Let's not directly do benzene to phenol, right? Okay. So, this you can erase. This too you can erase. Wait a minute. This you can erase here. Just give me a second. This you can erase here. You need to tell me, to convert phenol to benzene, what will be the correct answer? If you want to convert phenol to benzene, what will be the answer? For conversion of phenol to benzene, the answer is very good. The answer is zinc dust. Okay, what we are going to use? Zinc dust. If you want to convert phenol to benzene, then you are going to use zinc dust here, right? Now they are saying, if you want to convert benzene, firstly, though they are saying that if you want to convert, little bit mistake is here. I know that. Just let me make it right. Okay? Because there will be no conversion on this side. The conversion will be this one. Okay? This will be the conversion. Now you need to tell me, this is zinc dust if you want to convert phenol to benzene. If you want to convert benzene to, what is this name? What is the name of this particular thing? On benzene, you have isopropyl. On benzene, you have isopropyl. What is the name of this thing? What is the name of this compound? This is a very, very important process. This is called, very good, this is called, what is the name of this thing? This is called cumene. This is called cumene. Okay. So, whenever you are using cumene, you want to convert benzene to cumene, You can use anything. I'll just give you the reagents here. You can use CH3, CH2, CH2, Cl, and anhydrous AlCl3. This is the first way. Or you can also use CH3, CH2, CH2, OH, and this is H positive. You can use concentrated H2SO4, concentrated H2SO4 here, or you can just write here H positive. You can just write here H positive. So basically what will happen in this case? What will happen in this case? You will have the formation of a reagent, that is CH, carbocation will be formed, that is this one. After the rearrangement, it will be CH positive and CH3. It will attack on benzene, and hence you will have the formation of isopropyl benzene. So anything they can give you, right? Okay, they can also give you this thing. They can also give you this thing. If you have CH3, CH double bond CH2, right? Okay, and here they are adding H positive, or anything they can add by substituting. They can also add H positive, you can say, right? Okay, something like this also can be given to you, right? So basically you need to have this kind of carbocation. If anything is giving you this kind of carbocation, CH2, CH2 positive, that thing on benzene is going to form isopropyl benzene by the formation of this rearrangement and by the formation of this kind of carbocation, right? Okay. Now, next is from cumene to phenol. Now, from cumene to phenol, what we do, right? From Ma'am, H2 in, no, directly you can't use that, okay? Directly you can't. You have to make this particular carbocation, okay? After only then you will be able to make cumene. Now for this, what we will do? We will use O2, right? Then H2O2, right? Okay, which thing will be formed? This thing will be formed here, right? Okay, this will be C, this will be O peroxide bond will be there. After that, you will have the formation of phenol plus acetone. You will have the formation of phenol plus acetone will be formed here. Right? Okay, done. Chal, very good. Now that was the second chart that we did. After that, let's do this chart. Okay, this is the last chart. So I'll give you for homework only. Right? Let's do this chart. This is interesting. Okay, this is interesting. Let us see if you're able to do this chart. Now, this is moderate level of chart. After that, we are going to do big charts. Okay, this is moderate level, right? Okay, chalo. Now, ma'am, the reaction between cumene and benzene. I have not reacted cumene with benzene. Okay, there is no reaction of cumene with benzene. I have told you that firstly, what you will do? From benzene, you will have the formation of cumene. Then in cumene, you are adding O2 peroxide. Then you will have this peroxide linkage. After this, you will have the formation of acetone and phenol. This thing will be formed. Now, phenol is converted back to benzene with the help of zinc dust. This is the cycle that I told you. Benzene to cumene, cumene again to phenol, then phenol to benzene. This is the circle that I told you. Okay, chalo. Now, next is this particular reaction on your screen. Now, let us see who is able to answer this. Okay, let us see how many of you are able to answer this. So, firstly, I am telling you, there is no specific hydrocarbon that I have given here. Here, I want to see the knowledge for reagents that you have, right? If you talk about this particular thing, here you have a hydrocarbon. Here you have a hydrocarbon. Now, if you talk about a hydrocarbon, in presence of SOCl2, firstly tell me what is this reaction? This reaction is called Reed's reaction. Reed's reaction. In presence of SOCl2, that hydrogen of hydrocarbon is replaced by Cl, so answer will be RCl. That means A is RCl. Very good. A is RCl. After RCl, you are adding aqueous KOH. That means you are replacing this Cl with aqueous KOH. That means Cl is replaced by OH here. So here the answer is going to be ROH. Answer is going to be ROH. Now, I am saying that this ROH, it can be 1 degree, it can be 2 degree, it can be 3 degree. Right? Assuming that this alcohol is 1 degree, what is the answer for C? Assuming that this alcohol is 1 degree, what is the answer for C? If I am saying that this alcohol that is formed, it is 1 degree primary, then what is C? Yes, everybody? Okay? Yes, yes, beta, that is enough. But you also have to do practice your own self, right? After that, so without practice, so nothing is possible. Right? Now, if this is 1 degree, very good. If this is 1 degree, copper is going to behave in such a way that it will give you aldehyde here. So this C will be an aldehyde. This C will be an aldehyde. If you talk about, let's say this is 2 degree. If this if this ROH is 2 degree, then it is going to give you which thing? What is going to be D? Ketone, carboxylic acid, alkene. What it is going to be? Ketone, carboxylic acid, benzene, cumene. What it is going to be? Yes, with 2 degree, it is going to give you ketone. With 2 degree, it is going to give you ketone. So D will be a ketone, right? Okay. Now, with 3 degree, what it is going to give you? With 3 degree, what you are going to have? Tertiary alcohol with copper at 300 degrees Celsius, it is going to give us which thing? Aldehyde, carboxylic acid, ketone, alkene, cumene, benzene. What it is going to give you? Yes, everybody, direct question can be asked like this: A to B, B to C, C to D. If B is 3 degree alcohol, then what will be? If B is 3 degree, or they can say that if R is isopropyl, if R is isopropyl, then with a same question, that you will say, ma'am, this is such a high level question, right? They can give you the same chart. They can say that if R is this, if R is a 3 degree 3 degree alkyl group, then what will be E? We know that alcohol is formed here. If R is 3 degree, then the answer will be very good. Then the answer will be alkene. The answer will be alkene. Now you have to tell me, what is this G? What is this G? What is this G? If you want to convert alkene to alcohol, from alkene to alcohol, what you should do? From alkene to alcohol, what you should do? Yes. From alkene to alcohol, what should be the reagent that you should use? You should do the hydration, right? Here, you don't need to specify anything. Any hydrating agent can be used. You can use H2SO4 because we have not specified what is R, right? There is no specification, right? You can say that this G can be H2O in presence of acid. This can be B2H6 in presence of peroxide hydroboration. It can be oxymercuration, demercuration, right? Any of this can be the answer if you want to generate alcohol from alkene, depending upon which alcohol you want to generate here, right? Okay, depending upon which alcohol you want to generate, right? Okay. Now, what is this? This is reductive ozonolysis. They are saying that this C and D, what you have formed, this is formed by some F after the oxidative ozonolysis, after the reductive ozonolysis. So can I say that this F will also be alkene? This will also be some alkene here. Because we know that from alkene only we have the formation of aldehyde and ketone. Right? From alkene only we have the formation of aldehyde or ketone. So these things can be asked to you. Now they can also specify some things here. If you want to specify some things here, then I can also tell you how specification will be used here, right? If I specify few things here, then how it will be used. For example, I am specifying that for example, I specify that I am going to, chalo, let's not specify because otherwise it will become thoda sa complex, right? Chalo, let us start with the next one only because we have a lot of questions here, right? Now, here we are saying that this is the fourth flow chart that we are doing here, right? Okay, so this is a long flow chart. This is first page, then this is second page, this is third page. This reaction is going on, going on, going on. From A to we have to make L, from A to we have to make P, right? So basically most of the reactions of amines will be covered here. Most of the reactions of amines will be covered here. I'll give you one hint here, right? I'll give you one hint here that A is alcohol, okay? A is alcohol. A is alcohol. This is the hint that I am giving you. You can take alcohol as, you can take it as CH3OH. Take A as CH3OH. Okay? A is CH3OH. Yes, students. Achha, take A as CH3CH2OH. Take it as ethanol. Okay? Okay, kids. Shall we start, everybody? Bacha, this is a very, very interesting flow chart. This is a very, very interesting flow chart. Okay? Beta, OMDM is oxymercuration, demercuration. Now, I can see your answers. One by one we will answer, okay? You don't have to answer me full L you are solving. Full L you don't have to answer me one by one. First you answer me what is B. If I am writing that A is, this I am giving you. I am giving you that A is CH3CH2OH. Now you have to tell what will be B. I am telling you that A is CH3CH2OH. You have to tell me what is B. What is B? Proper name will be there now. Okay. So we are using H2SO4, which is a good dehydrating agent. That means OH will be taken out, H will be taken out here. The answer will be CH2 double bond CH2. Right? Alkene has been formed here. After that, I am adding Br2CCl4. Right? Br2CCl4 means it will break the pi bond, and here you will have the addition of Br and Br on both sides. So answer will be CH. This will be Br. This will be Br. After that, I am adding KOH and NaNH2 two times. See, when I am adding KOH, that is I am adding a base here. Right? Firstly, it will take out one hydrogen and Br from here. Alkene will be formed. Right? Then again I am adding one more base here. It will take out another carbon and hydrogen here. So here you will have the formation of another carbon and hydrogen will be taken. Carbon I am saying. Another hydrogen, basically this will happen. This is C, this is C, this is H, this is H, this is H, Br, and this is Br. Right? Firstly, one base will take out this Br and this hydrogen from here. Double bond will be formed. Then another base will take this Br and this hydrogen from here. One more pi bond will be formed. So you will have, very good, you will have the formation of ethyne here, right? So it will be CH, or you can just directly write C triple bond CH, and this is H. Now, beta, what is this RHT? What is this RHT? What is RHT? Red hot tube, iron or quartz you can use here, right? So red hot tube, it is going to give you which thing? Red hot tube, ethyne, red hot tube. It is going to do the, what is this? What is this? Do the RHT, beta, red hot tube. Okay, red hot tube, RHT, iron or quartz you can use here. Aromatization. So from aromatization, what will happen? This triple bond, this triple bond, this triple bond, it is going to shift here, here, and eventually you will have the, very good, you will have the formation of a benzene here, right? A benzene will be formed here. See, the starting was from alcohol and now you have formed benzene. Right now, all the reactions that we will be doing will be for benzene, aromatic, basically aromatic compounds we'll be using here. After this, basically this is what nitrating agents, right? This is going to add nitrogen on the nitrogen. It is going to add NO2 group on the benzene ring. So that means F is going to be over this, you will have the NO2 group here, isn't it? Over this, you will have the formation of NO2 group here because NO2 positive electrophile will be generating. Very good, nitration will happen. After this, either they can also give you here, tin can also be given to you. Here they can also give you tin. Okay, they can also give you SN or tin. That will be the same answer. Okay, that will be the same answer. Now, on nitrobenzene, you are using tin or iron HCl. Very good. Here we are doing the reduction. Shabash. I am now very proud of you that you are able to answer these questions. Trust me, guys, if you are able to answer these questions, you are good to go for organic chemistry. Right? Now, here we have, this is NH2. Okay, this is aniline is formed. Now, aniline is showing some circle here. Some circle we are seeing here. Some circle is formed here. Now, let us see. Let us try to understand what is H, what is I, what is I dash, what is J. Okay? What is H? Chalo. Now, on aniline, what I am doing here, on aniline, I am adding some compound, some reagent that is NaNO2HCl. What I am doing? Yes, I am doing the diazotization, right? So here I'll be forming disonium, benzene disonium salt will be formed here, that is N2Cl will be formed here, right? After that, I am adding CuCN and KCN. CuCN, basically Sandmeyer's reaction, right? So here, this will be just like Sandmeyer's reaction, this will be CN will be placed here. That means I is cyanobenzene. Very good. After that, I am doing the hydrolysis. So whenever you have C triple bond N, you do the hydrolysis, it will be shifted to double bond OOH. That means benzoic acid will be formed. So I dash is nothing but this is benzoic acid. So here answer will be benzoic acid. Now, they are saying that in benzoic acid, you have added NH3. Now, what is J? Now, I am waiting for your reply. What is J? You have this thing. This is C, double bond O, OH. You are adding NH3 here. What thing will be formed? That means what will be J? What will be J? What is J? Everybody. And they are also giving you one hint that J is that thing where after Br2NaOH, some reagent is given, you have the formation of aniline here. Yes, very good. J is benzamide. That means this OH is replaced by NH2. This OH is replaced by NH2. So you will have the formation of CuNH2, that is benzamide. So you can just write it here, benzamide. Benzamide, that means amide group will be generated here. Now, from amide, you are just what you are doing? This CO, this thing is eliminated and here you will have the formation of aniline. Now, CO is eliminated. That means this is what reaction? What is the name of this reaction? Anybody in the comment section, what is the name of this reaction? You have amide to aniline, benzamide to aniline. Very good. This is called Hofmann bromamide degradation. So you can just write it here. This is Hofmann degradation. I don't have that much space. Hofmann bromamide degradation. Okay. So this chart is not yet completed. Okay. So again, after this, after completing, we have I dash and J. From here, this is F na. What was F? F was, wait a minute, F was nitrobenzene. I'll just write it here. F was nitrobenzene. Beta, I didn't have that much space. So that's why I wrote this on different pages only. Right? So this is nitrobenzene and after this you have the formation of aniline. This was your aniline, right? Okay, this was aniline. This was amide. This was amide, right? This was benzoic acid, right? This was this was N2Cl, benzoic. This is sodium benzene disonium salt, right? And this was Cl, right? Now they are saying that in CN, they are saying in CN, you are adding some NaHG, that means sodium amalgam and ethanol. In CN, you are adding sodium amalgam and ethanol. That means this is the thing that you have. This is the thing that you have, C triple bond N. You are adding sodium amalgam and ethanol. Anybody in the comment section? Sodium amalgam and ethanol. Is this a reducing agent? Is this a oxidizing agent? Is this a reducing agent or this is a oxidizing agent? Is this a reducing agent or this is a oxidizing agent? What is this? Yes. Here, pi bonds will break and you will have the addition of H2H2 on both sides. That is the work of sodium amalgam, right? So here what will happen? You will have the formation of this benzene. On benzene you will have CH2 and this is NH2, right? Till K we are sorted. After that we are using Hinsberg reagent. Hinsberg reagent we are using. They are saying L is formed here, which is soluble. This is a hint that is given to us. Now beta, understand one thing, that this is a primary amine. So whenever you have a primary amine, in that case, Hinsberg reagent, here it will be SOCl, SO2Cl, right? Okay. So here which thing will happen? Here basically H and Cl will be eliminated and hence you will have the formation of this benzene. This will be S double bond O. This will be, from here you will have NH, and this is CH2. Again it is benzene. This thing will be formed here, okay, which is soluble. Okay, got it now? What I did here, hydrogen from this side is eliminated and Cl from this is eliminated, right? So benzene, S double bond O, then NHCH2 and benzene. Now here we know that here you have, on nitrogen you have one hydrogen, that is why it is soluble in the alkali, right? Okay, one more question they can ask you, that you have the formation of L. Now you have to tell L is soluble in alkali, it is insoluble in alkali, it does not react with Hinsberg reagent, it is not a nitrogen compound. Anything can be given to you, right? Okay, but this is not a azo compound, okay? This is not a azo compound, okay? This is Hinsberg reagent. Hinsberg reagent, what we do, that you have RNH3. For example, you have RNH2. This is primary. And here this is benzene. This is S double bond O, and this is Cl. So if you have R, this is nitrogen, this is H, and this is H. What will happen in Hinsberg reagent? HCl will be eliminated from this side, right? And hence you will have the formation of this thing. The nitrogen here will be bonded here. Now here it is the same thing, it's just that what is R? R is CH2 benzene. So that is why here this is benzene, SO2, N, H, till here to everything is same. Now what is this R part? R is nothing but benzene and over it you have CH2. Okay, got it? Yes, Harish, got it? So this is primary amine, right? Understood? Very good. Very good. Minhaj also given the IUPAC naming here. Very good, Minhaj. Very good. Now, this we have solved. Now, third, this is the same reaction it is going on. Same reaction is going on. What was G, guys? G was aniline. G was aniline. Now, they are also giving you one more reaction here. That means basically this chart that I told you, this is 1, 2, 3. It is basically, I'll also show you, I made it in A4 page, so that's why I was able to write it there, but on iPad I was not able to write all the reaction. It was getting very messy, right? So that's why I wrote it on different pages, right? Now here third is from G you have the formation of H and I, that we know. H is what? H is diazotization. You have the formation of diazonium salt here. This is so simple, right? Here after that you have the formation of Cl. After I, we have done the reactions here. After I, we have done the reactions here. But after G, they are giving you some another set of reactions. Some another set of reaction is given to you. Now they are saying that you have this aniline. On this aniline, you are doing CHCl3QH. Now can you tell me what is this test? Chinu, very good, yeah, very good. CHCl3QH. It is same as Reamer-Timmer reaction, right? But ma'am, this is not phenol. This is aniline. So basically, we are talking about carbylamine test, okay? We are talking about carbylamine test or isocyanide test, right? From here, we have the formation of isocyanide. That means you will have the formation of NC from here. Here you had the formation of, somehow you had the formation of CN. Here we are doing the reaction. See, same thing we are doing here. Here we had the formation of CN. Then we added sodium amalgam. You had the formation of 1 degree amine. Then Hinsberg test. Now, in this case, what I am doing is, I have made isocyanide. Now I am doing the same reaction. Same thing will happen. Same thing will happen. You will have benzene and triple bond C. 2 pi bonds will break. 2 pi bonds. 2 pi bonds will break, right? And here you will have the formation of NHCH2. NHCH2. Here it will be CH3. So here the answer will be after sodium amalgam, there will be reduction and the answer will be NHCH3. Now beta, tell me what kind of amine this is. 1 degree, 2 degree, 3 degree, right? Okay, 1 degree, 2 degree, 3 degree, what kind of amine this is? As you can see, nitrogen is bonded to 2 carbons, so it is a 2 degree amine. It is a 2 degree amine. That is why 2 degree amine on Hinsberg reaction is insoluble in alkali. That is why it is insoluble in alkali. Now I'll tell you how you can make the reagent here. Basically, it is benzene. Then you have S double bond O, double bond O. Cl is eliminated and from here hydrogen is eliminated and that nitrogen is linked here. This nitrogen is linked by one CH3 and one benzene. Okay, or you can just directly write here phenyl. So this thing will be formed. Why it is insoluble? Because it does not have any hydrogen here. That is why it is insoluble in alkali. Now everybody tell me, is that thing clear to all of you, right? You can just write it down on some page yourself. It will really help you to remember all the reactions, right? In this way, your brain will work more effectively. It's like a brain exercise only that you are doing for organic chemistry. Okay, students, is that clear to everybody? Is that clear to everybody? Now we will be jumping on some difficult reactions. Not difficult, you will find it easy also, but yeah, that is more of like some new reagents will be added there, right? So level will little bit up, okay? Level will increase, right? Here, so I was just telling you that how they can ask you. See, students are saying, ma'am, how many questions? Can you tell me in one chart how many questions you covered? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think in one chart we have covered some 20 questions here. Right, okay, till now we have done from all these charts, this chart, from this chart, from this chart, this one and this one. We have covered around 40-50 reactions easily we have covered, right? Now we'll be coming to, okay, and I'll be picking some good reaction. This is also good. You will be excited to answer this, है ना? You'll find it very encouraging to answer these kind of questions, okay? Yes, so everybody in the comment section, Firstly, you have cyclohexane. On cyclohexane, you have Br2H mu. Yes, everybody, on cyclohexane, you have Br2H mu. Now, if you talk about on cyclohexane, you have Br2H mu. This is a free radical mechanism. It will cause substitution. Very good. Substitution will happen here. That means one hydrogen will be replaced here. One hydrogen will be replaced here with bromine. That means this kind of thing will, it will become, right? Or you can just write down this thing, right? For easy things, you can just write down it like this. Okay. Right? Now, big questions will be asked here, right? After this, you are using aqueous NaOH. With aqueous NaOH, aqueous NaOH means which thing? Aqueous NaOH, the one drinking water simply just like your ma'am, right? After that, what will happen? It will substitute the halide here, right? So that means it will have the, you will have the formation of OH over here, right? OHO, not phenol. Not phenol. This is not phenol. This is not benzene. This is cyclohexane. Okay, this is not phenol. Acha. After this, concentrated H2SO4. Concentrated H2SO4 is a dehydrating agent. Hexanol is, cyclohexanol is formed. It is a dehydrating agent. It will take out OH from here and one hydrogen from this side, right? Then you will have the formation of a double bond on this position, right? Okay, a double bond on this position. Cyclohexene is formed. Very good, cyclohexene is formed. After that, again they are adding Br2CCl4. See, Br2H mu, it causes substitution. Br2CCl4, it will do which thing? Br2CCl4. It is going to break the pi bond and add Br on both the positions. So you are going to add Br on both the positions. So here it will be Br. This will also be Br. Right? This will also be Br. Conversions are the best, guys. Conversions are the best. Okay. After that, you are adding NaNH2 in excess. That means here what you're going to do, everybody, you're adding NaNH2 in excess. So basically what will happen here, no? So this is hydrogen, this is hydrogen. With one NaOH, with one NaNH2, one Br and hydrogen will leave, right? And hence you will have the formation, I'm just writing E here. You will have the formation of, when one NaNH2 will be added, one dehydrohalogenation it will cause, right? So one Br and hydrogen will be eliminated, one double bond will occur here, right? One double bond, right? Again, you are adding NaNH2, one more hydrogen and Br will be eliminated, and hence you will have the addition of one more Br here, right? One more Br, one more double bond is present here. Now they are saying that you are adding NBS, N-bromosuccinimide. N-bromosuccinimide. What is this N-bromosuccinimide? N-bromosuccinimide, Br2 in presence of H mu. These were doing the same thing. I told you this is an important reagent. Very good, Ramini, very good. This is doing which thing? Chinu, here it will not be triple bond. The answer being this is a cyclic chain, right? So in cyclic chain, it is difficult to have triple bond. There is not that much stability. That is why it will prefer two double bonds here. Okay, understood? Here it will cause allylic substitution. That means here what will happen? This allylic position, can you tell me which is the allylic position? This is the allylic position, right? So in this position, what you will see that there is formation of this Br, right? Addition of this Br here on the allylic position, right? Till here, any problem? Very good, Minhaj. Very good. After that, you are again adding alcoholic KOH. Ma'am, alcoholic KOH, so dehydrohalogenation. Beta, alcoholic KOH, dehydrohalogenation. NaNH2, dehydrohalogenation. NaNH2 can cause even faster dehydrohalogenation as compared to KOH, right? Okay. Now, again, this is one hydrogen, this is halogen. Dehydrohalogenation will cause a double bond over here, and G is going to be a benzene ring. Okay, understood? That's why I showed you that the flowchart that I gave you here, wait a minute. The flow chart that I gave you here, we were forming benzene from alcohol, right? Here what they are doing? They are forming benzene from cyclohexane, right? Using different reagents, right? Okay, next. Ma'am, we have benzene also. Now, ma'am, what to do? Once you have benzene, now what to do? With the benzene, you are adding this thing, that is this kind of thing that you are adding here. Wait a minute. I'll just show you the reaction, because this is your JEE question only, right? Okay, that's why I'll just show you, because here students get confused, right? Okay, so this is benzene. This is Friedel-Crafts acylation. This is basically Friedel-Crafts acylation. Okay, this is nothing but this is Friedel-Crafts acylation only. I'll tell you. This is nothing but this is anhydride. Okay, this is an anhydride and this is a benzene. What will happen? You are using anhydrous AlCl3. You are using anhydrous AlCl3. Now, guys, Friedel-Crafts alkylation will occur. Friedel-Crafts acylation will occur here, right? So, what will happen? This bond, you can say, this electrons will jump here, and hence you will have the formation of this anhydride as something like this. This is double bond O. This will be positive. This is going to be negative. So this positive is going to attack on the benzene. So that will be benzene here. It will be this benzene here. And on this you will have the addition of this positive double bond O. Right? Then you will have one more carbon. Then you will have COO negative. This thing will be formed. Got it? Friedel-Crafts acylation. How I did that? Benzene as it is. Then I know from here, this positive, this thing is going to attack on some benzene atom, right? On some carbon atom of benzene. So this is benzene, C. This is C, double bond O, C double bond O. Then one carbon, two carbon, C double bond O, O negative, right? Okay, got it? Any problem here? Beta, this is the most important step. And this is the most confusing step of this particular flowchart. Okay, got it or not, everybody? Here you had the addition of this thing, right? After that, we know that here what will happen eventually, hydrogen will be placed here, right? And hence this thing will be formed. So you can say CO, you can also write it as benzene. This can be written as benzene, CO. This is COOH. This thing will be formed. Right, so I'll just write it here. This will be, let me just write it here, benzene. This is C double bond O, 1, 2, this is COOH, right? Okay, COOH. Oh, 1, 2, 1, 2. And then you have COH. Just writing it here. Okay. Now you're adding zinc amalgam, HCl. What is this? This is nothing but this is clemenzin. This is clemenzin reduction. This is clemenzin reduction, guys. Clemenzin reduction, right? That means CO2H2. Very good. CO2H2. That means this thing, this CO will be replaced by, don't worry if you feel that, na ma'am, how after when you will give the notes, how we will be able to like understand what you have written, what is H, what is C. So already the solution in a proper way I have written, already we have written here. You don't need to worry about that. Right now just focus on understanding what I am telling you. Right. So here you will have the formation of, this is benzene, and to this double bond O, C double bond O will be converted to CH2. 1, 2 carbon, and this is COOH. Now they are saying you are adding concentrated H2SO4. Now beta, you are adding again concentrated COH, concentrated H2SO4. Concentrated H2SO4. Now everybody, concentrated H2SO4. Anybody in the comment section? Oops. See, I'll just write it on the next page only, because this is again a very, very important reaction, right? So usually students get this reaction wrong, right? That's why all the reactions that are important, that I know that it is difficult for you to answer like verbally, that's why I'm writing it here. So basically we have made this benzene. On the benzene you have CH2, this is 1, or you can just write, say 1, 2, 3, and this is C double bond O, this is OH, and here also you will have 1 hydrogen. Okay, so what will happen here? Concentrated H2SO4 is dehydrating agent. It will eliminate water. So it is going to eliminate OH from this side. It is going to eliminate H from this side, and this carbon and this particular carbon, they will join together, and you will have the formation of, this is basically concentrated H2SO4. Here you will have the addition of, here you will have the formation of benzene. This is 1, 2, 3. This is 4. Wait a minute. This is benzene, right? And this is 1, 2, 3. This is 4, and this is double bond O, right? This thing will be formed. Okay, bacha? Understood how water is removed from this particular thing, right? Very, very important. Is that clear to everybody? How water is removed from this particular place, right? Okay, wow, yes. Okay, yeah, this is wow. Now I'll just write it here, right? Okay, it's very difficult, guys, to write it here. So I will write it somewhere here. So this will be benzene. It is 1, 2, 3. This is double bond O. After that, we are adding too many things, na? Too many things. So I'm gonna erase this particular thing. I'm just copy pasting this thing here, right? And I'm going to erase all of these part, all of this, because otherwise it will be too much mess, है ना? So we also need like some space to write down. That's why I'll be writing other reactions over here. Okay, I'll be writing other reactions over here. Okay, very good. This is Grignard reagent. Now, ma'am, Grignard reagent, how it is going to behave, guys? How it is going to behave, Shabash? How it is going to behave? Now, again, we have like a proper set of reactions here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 reactions still we are about to do, okay, to complete this particular chart. So this is, I'm going to show you here. This is benzene, this is benzene, this is double bond over here. So I'll just write it like this, okay. This is Me, that means CH3 MgBr, okay. CH3 MgBr, guys, let me tell you one thing here, what will happen. This is partially positive, this is partially negative, same thing. Partially positive, partially negative. So it will attack here. And what will happen in this case? It will attack here. This is your compound. In this case, this carbon, electrons will jump here. It will have the formation of O negative. This will be O negative. This is basically O negative. Right here, you will have the attachment of CH3. Right? Okay, this thing will be formed. To this O negative, you will have the attachment of MgBr here. And after the hydrolysis, let us see if they have given us hydrolysis or not. They have given us hydrolysis in this step only. That means this MgBr, is converted to OH, right? Is converted to OH. So can I say this thing will be formed? Can I say this is which product? This is K. Okay, this is K. Here I can write, hai na? This is K. This is K. So let me just write it down here. This is K. This is nothing but this is K only. So I'm just writing it here. This is K. After K, what you are doing? After K, what you are doing? After K, you are adding concentrated H3PO4. Now, beta, what is concentrated H3PO4? What is concentrated H3PO4? Can you tell me what is the work of this reagent? Concentrated, ma'am, please explain, please. Okay. Beta, see, what we did here, we know that this is CH3MgBr. Always Grignard reagent will behave the same way, right? This is partially negative, this is partially positive, right? This is partially positive, this is partially negative. This negative is going to attack. This negative is going to attack on this positive carbon. Electrons will jump here. You will have CO negative. CH3 will be attached here, and here you will have the attachment of MgBr. After hydrolysis, OMgBr is converted to OH. Understood? Now is that clear? Right? Okay. Now, next is we have concentrated H3PO4. Right? Okay. We have concentrated H3PO4, guys. Very good, Harish. This is dehydrating agent. This is a dehydrating agent. And when we talk about dehydrating agents, that means it is going to take out water from here. Now tell me how it is going to take out water. But these reactions I can't teach you here, right? Because they are complex reactions, okay? So that's why I have taken up a different page to show you that. So basically, OH negative will be eliminated here. And beta is also, this one is also beta, this is also beta, this is also beta. Here double bond can't be formed because here you have benzene ring. And here what will happen, you will have more alkylated, according to Sedgwick rule, you need to have more alkylated alkene should be formed. So that is why here you will have the release of H positive and it will be formed here. So answer is going to be this benzene, and to this you have the attachment of C. This is CH3, or you can just write it like this. Wait a minute. You can just write it like this. CH3, and this is double bond. Right? Okay, guys. Okay, everyone. Understood or not? Now we have done K also, L also. After that, you are doing, what is this thing? What is this reagent called? What is this reagent, everybody? What is this reagent, everybody, in the comment section? Enjoying it or not? Enjoying it or not? Or you're finding it tough? Right? Okay. Ozonolysis. Now this is reductive ozonolysis, right? Very good, beta. Very good. Reductive ozonolysis. First, I want to know if you guys are enjoying this or not, right? Because it takes a lot of efforts to make these kind of things for you. It's actually time consuming. Okay. Now, after that, we will be adding O3Zn. That means break the double bond, attach double bond O. So this is what we are going to do here. So this is your product. Here we are going to break this double bond, attach double bond O here, attach double bond O here as well. So this is going to be the answer, right? Okay, this is going to be the answer for reductive ozonolysis, right? Okay, reductive ozonolysis. After that, what we are doing? After reductive ozonolysis, we have done till M. Till M we have done. Then we are adding LiAlH4. This is a reducing agent. It will convert the ketonic part to OH part. Very good. Very good. Which is the doubt, Bicha? Which is the doubt? Super effective, ma'am. These classes are very good. Very happy to know that. Right? I try my best not even to waste even a single minute of you guys. Right? Because I know how important this. See, I feel blessed that you guys are trusting me to give your time, this beneficial time to me. That's why I give my 100% so that every single minute that you're devoting here will be beneficial for you, right? Maybe it will be 10 times more beneficial, right? Okay. Yes. Learning new things in chemistry. Very good. Happy to know that. Now, LiAlH4 you have here. Here what we are going to do, this is benzene. This is going to convert double bond O into OH. So this double bond O is converted to OH, and this double bond O is again converted to OH here. So I'll just write it here. Okay. So this is going to be double bond O, OH. You can also write it like this. This is going to be the answer. Not the answer. This is, I think this is N. है ना? This is N. Till N we have. Acha, everybody. OPQRS. OPQRS. Let's see how many of you can answer this. What is SOCl2 and pyridine? This is also a very good naming reaction only. SOCl2 and pyridine. Shabash, everybody. SOCl2 pyridine. What is the name of this reaction? What is the name of this reaction? Very good. Very good, very good, very good, beta. Very good. Happy to know that. Ozonces affect benzene. Why ozonces? Beta, ozonces will not affect benzene ring here. Okay? It is under conjugation. It is under resonance. Okay? The bonds are under resonance. They are not proper double bonds. Right? Okay. Okay, Madhu? Yes. This is called Darson reaction, and you guys make me so happy that you can recall everything. That makes me so happy that you are able to recall anything. I am so happy that the chat box is not blank. Otherwise, I was scared that if you guys find that, okay, ma'am, I am not able to recall anything. That's why I properly took 4 days. Firstly, though, I was thinking that directly I should give you these flowcharts. Then I thought that what if some of you have not done the reactions properly? That's why I took 4 days only for this day. Only for this day. Right? Chal. Now this is Darson reaction. It is going to replace OH with Cl. So you're going to replace OH with Cl here. So this is going to be SOCl2 in presence of pyridine. So it is going to replace OH with Cl. So you will have the answer as this is OH, this is Cl, this is again this is Cl, and this is CH3. Okay, that is going to be the answer. Yes, everybody. After that, what you have? After that, you have this also we have completed. Now, what is NADE? I'll just tell you here what is DE. D is dry ether. D is dry ether. Hydrocarbons, Wood's reaction. If you remember, I told you that when you have dihalides here, when you have dihalides only in one case, right, it will form, when you have Na in presence of dry ether, you will have the formation of, this is benzene, and here you will have the formation of this free radical, and here you will have the formation of this free radical, right? Now, they both will combine together. These two free radical, they will always prefer intramolecular. When they will prefer intermolecular, when there is some anti-aromatic product is formed, right? So that means here no anti-aromatic product is getting formed. So that's why simple what you will do here, you will attach these two things together, right? Okay, is it fine? So intramolecular, very good, very good, very good. Shabash. Oho, kya baat hai? I think the preparation is going on point. The preparation is going on point, ma'am. Now I can feel that Josh in the comment section that yes, ma'am, the preparation is on point. We know, ma'am, this thing also. Right? So this is, if I need to write it in a better way, right? So that in more presentable way, we can write it like this. Okay? So this thing is formed here. Right? Okay. Acha. Okay, where we were. This also we have done. P also done. What is PDC? What is PDC? Wait a minute. This was the wrong thing here. It was not supposed to be PDC. Okay, this is by mistake. They have written PDC here. So I'll just correct it here. Okay, sometimes typing error happens, no? Because they are not the GD, the graphic designer makes these slides. No, we to just give them the flowcharts. So sometimes they don't understand what we have written. Right? So here basically you are using very high temperature. You can just write here RHT. You just write here RHT. Now tell me what will happen. Here, I'm just taking out one more page here. I'm taking one more page here because reactions are so big that I can't write it on one page, just one page, right? Okay, so here after this, what we are using, you are using RHT, that is to cause aromatization. Aromatization of which thing? This will be aromatized, right? So you will have two benzene ring joined together and this will be CH3, isn't it? Yes, very good Chinu, very good Chinu. Yes, everybody. Now, next what we'll do? Formation of benzene instead of cyclohexane. Right, after this what you have? Now you have also completed this Q part here. After that you have, what is this R and what is this S? Two things we are left with, R and S, R and S, R and S. R is, you have added Cl2 in presence of H mu in excess. That means this is a free radical mechanism, right? This is going to cause substitution reaction, right? Substitution reaction we can't do on benzene, these double bonds, right? So we know that this is CH3. Here we can do the substitution, right? Here we can do the substitution, right? So it will be, this is Cl2 H mu. So here the answer is going to be, this is this is going to be, okay, this is CCl3, okay, CCl3. After that what we are adding? The last part, beta, the last part here, the last part is aqueous NaOH. Then you will add aqueous NaOH. What will happen? Anybody in the comment section, what is the work of aqueous NaOH? Aqueous NaOH. Aqueous NaOH will substitute Cl2. Aqueous NaOH will substitute Cl2OH, right? Okay. So let's substitute that thing. This is going to be very, very important for you. Reason being, wait a minute. Aqueous NaOH. Okay. So here it is going to be, this is COH, OH, OH. We know that so many oxes, OH, OH are not stable on one carbon. So what will happen? OH will be taken out on this side, right? You can also take out one hydrogen from here, one hydrogen from here you can take out, right? Bond is shifted here, right? And hence you will have the formation of, and hence in the end you will have the formation of, this is C, this is double bond O, this is OH, right? So which thing is formed? COH is formed here, right? Okay, nathoic acid. Very good, very good. Ma'am, I have doubt, why are you remove all H and add Cl? Ma'am, why have you all H? Because we are using Cl2 H mu. That means substitution we are doing here, na? We are doing the substitution and here they have given in excess. In excess. In excess means we are not stopping there. We are adding one more. Okay? Understood, Jenny? Very good. Very good. Chalo. Understood, guys? This was interesting or not? That was interesting, right? So that's why if I showed you this reaction in the start of the lecture, now everybody will be like, ma'am, okay, tata, bye-bye, ma'am. Tata, bye-bye, ma'am. We are not, ma'am, we are not going to do this. That's why I started with a very basic flow chart. Then I am increasing the level with every single flow chart. Okay? Yes? Chalo. Super interesting. Good revision. Acha, do you need 1-2 minutes break? Do you want to talk to me for 1-2 minutes? Beta, this is the full chart that I'll just correct few things here. Let me see. There is some incorrection here. Let me just see that. Okay, so this is going to be, this will be RHT, right? Okay, Is there any thing that I need to correct? Everything else is right. Okay, so you can just go through this chart in the end, right? Okay, you can just go through this chart in the end, right? Here also it will be not S, here it will be any other mistake that you can see here, because I don't want students to learn through mistakes, right? Like from these mistakes, right? I think everything else is sorted. Only OH, Cl, Cl, and here it will be Cl and Cl, CH3. This will be this CH3, CCl3, COH. Okay, done. Done. Okay. But all the previous year, I have picked up the previous year questions, but these are more important than previous year questions. Okay, these are even more important than previous year questions, right? This is actually a combination of all the previous year questions that you are seeing here, right? Okay, from here to we have again done some 20 questions, so we have done here, right? Okay, chalo. Now this chart is also done and dusted. Next is this one, next is this one, or you want to solve the first one. Chalo, let's solve this one. Two charts, guys, we are left with. Two charts we are left with. Two charts, okay? Two charts. Chalo, shabash. Everybody, let us start with this one. Krishna, that will be provided on a Telegram channel of Vedantu JEE English. And you can also get this on the Jungle Box. That will be updated. Okay? Yes, those students who are watching it after like such long time, then it will be difficult for you to find it on the Telegram channel. So you can just click it down. Here it will be the link for Jungle Box will be there in the description. There you will, corresponding to this lecture name, you will get the PDF. Okay? Very good. Now, here you have, this is CH3, CH2OH, and you are adding NaOCl here. You are adding NaOCl, right? Okay, this is last two flowcharts are little bit tricky, okay? So, yeah, I know it is very complex, okay? 23 you have to do here. 23, guys. 23 reactions we have to do here. 23, can you just imagine? 30 minutes, so it will take us to solve this particular. And here we are going to, do 23 questions on this one single page. Okay, so first is CH3, CH3, CH2OH. What it is going to give you, this will be CH3, this will be CH, this is CH3. What it is going to give you, CH3, COONA, and this will be CH. Everyone, what will be 1? Everybody in the comment section, what will be 1? Everybody in the comment section, what will be 1? This will be CH. See, when you basically, this is actually a reaction. You can say this is. Can you tell me what is this name of this reaction? First, you tell me that thing. Can you tell me what is the name of this reaction? How many? First, I want to see that how many of you can identify what is the name of this reaction. First, you need to identify the name of this reaction. Very, very important reaction. Harish is able to identify. Very good. What is the name of this reaction? Haloform test. Haloform test this is, okay? Haloform test this is. Basically, it is chloroform test. So, basically, what we are doing here now, you have CH3, you have C, CH3, you have H, or you can just write it like this. CH3, COH, H, CH3. We know that when you do the haloform test, I'm going to write it down here that this is haloform test. Okay, this is haloform test. Haloform test. Okay, so it is how I predicted. NaOX is haloform test only, right? NaOCl we have. So it is going to give us what they have written in here. It is CH3COONA. With this carbon, it is going to give us the sodium salt, plus it is going to give us CHX3. X here is Cl, so it will give us CHCl3. It will give us CHCl3. Okay. Now, we have to do the reactions with this CHCl3. With this CHCl3, you are adding Ag powder. You are adding Ag powder, guys. Ag powder. Okay, second reaction is you have CHCl3. You are adding Ag powder. It is going to take out chlorine from here. Okay, that I'm giving the hint. Basically, Ag powder, now how it is going to behave, how it is, I'll just give you one simple thing here, that this will be CHCl. It will be CCl, and this is H. So it is going to take out all the Cl's here, and it is going to give you which thing, beta? This is a work, it doubles the carbon here, okay? Ag powder will do this thing, okay? So this is the work of Ag powder. This is C, 3 bonds, right? H, and this is H. Got it? Alkyne will be formed here, okay? Alkyne will be formed here. And interesting, na? New reactions you are learning. We are not repeating the same reactions. The best thing about these flowcharts is we are not repeating same reactions. We are learning new reactions here, right? Okay, this also done, this is done, this is done. Now everything is simple. Now most of the reactions are like, you already know. We have done this in last 2 days. Fe tube red hot. That means RHT, red hot iron tube. Red hot iron tube with this acetylene, or you can say this, what it is going to do with ethyne? It is going to do aromatization. It is going to form a benzene ring here. It is going to form a benzene ring here. After benzene ring, you are going to use AlCl3 CH3CO. What is the name? Beta, very simple reaction. Very simple. Very simple. The problem is that when you have so many reagents, students get confused only. And I know that it's not your problem because you have never seen so many reagents on one single page. That's why it is difficult to identify that which reagent exactly this is. And this is what happens in exam. It's not like you have not studied. It's not like you don't know the reaction. You know the reaction, then you say after coming back from the exam, I knew this reaction. I don't know, I was not able to recall it in the exam. Because you have not faced that situation. You need to give your mind that much stress that this mind is able to recall even in stressed situations. Okay? Now, very good stories for you. Can you please write it down in English? Right? That would be better and I'll be able to understand that. Okay? Yes. Now, this is AlCl3 CH3 COCl. Now, it is going to do Friedel-Crafts acylation, and it is going to give you, shabash beta, it is going to give you which thing? It is going to Friedel-Crafts acylation. It is going to give you which thing? This is benzene. Over it, you will have the formation of C double bond O CH3. Isn't it? C double bond O CH3. Yes, ma'am, it is done, ma'am. Done. Okay, this is also done. Then you are adding Br2 iron. That means you are doing the bromination here, right? Now, first you need to tell me, is this group meta-directing or this is para-directing? For next reaction, you need to know whether this group is meta-directing or para-directing. I told you that if you have a benzene ring, if it is attached to a group which has lone pairs, then it will show plus M effect, it will be ortho-para-directing. If it is attached to a group which is further double bondedly attached to a atom which is more electronegative, then it is going to pull out the electrons from here and it is going to show you minus M effect. That means minus M effect means it is going to be meta-directing. So if you see this here, this carbon is doubly bonded to oxygen which is more electronegative. That means it is going to be, yes, it is going to be, very good, meta-directing. Shabash, it is going to be meta-directing. So you can just write it here, it is going to be meta-directing. Okay, meta-directing. Okay, guys. Now, Next is, here it will show meta directing nature. So on meta position means, what is the meta position beta? What is the meta position? This is COCH3. Meta position, ortho meta para. This is the meta position, right? So on the meta position, you will have the formation of this Br, right? Okay, next is also done. Now this one is very interesting. Okay, I'll give you one hint here. This is basically ketal formation, hemiketal. There I told you in reagents also. Then when we will use ethylene glycol, right? Okay, that means we are basically forming ketal here. So I'll show you the reaction here as well. Right, on the next page, I'll just show you the reaction here. This is basically COCH3. This is O. On this you have COCH3. This is CO. Let's write it like this. This is CO. I'm going to write CO here. This is CO. There is some reason behind that, right? Reason is because we don't have that much space now. So this is going to be meta, right? For this carbon, this is going to be meta, right? Okay. Now you need to tell me how it is going to form. The answer. Yes, bacha. Now, here it is going to show the reaction with ethylene glycol here, right? Where was ethylene glycol? This is ethylene glycol CH2CH2OH. I'm just placing it here so that we are able to, we don't have to change too many pages. CH2OH and CH2OH. Okay. Now, chalo, let me write it this way. This is CH2, this is OH, this is OH. What is going to happen here? H from this side, O from this side will be eliminated, and hence you will have the formation of, this benzene. On this, very, very important, this is the carbon, right? Here you will have CH3, right? Here this will be one bond, another bond. This will be OCH2, OCH2. This thing will be formed here, right? Got it? This thing will be formed. Got it now? How I formed this? CH3, this is OCH2, OCH2. It is already linked, right? Okay. Very good, Shrikant. Very good. Oxygen, because we have formed the ketal here, it is basically acting as a protecting group here, right? It is acting as a protecting group. That is why we form the ketal in so many places, right? Okay, chalo. Now, here, beta, what we're going to do next is you can also write it. See, if you want to write it in a better way, you can also write it like this. Okay, you can also write it like this. It will be, this is C, this will be 1, 2, 1, O, O. Isn't it the same thing? It's just that if I write it this way, you will be able to answer it like, ma'am, yes. Here also I have written the same thing. C, C, CH3, CH3, O, 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 CH2, 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 CH2. Okay, this is the same thing that I have written. Okay, understood? Right? Understood, guys? Any problem here? Bachcho? Any problem here? Bachcho? Any problem till here? Right? Okay. So that is going to be the answer for, sixth one. After that, you are adding Mg ether. You are adding here Mg ether. Yes, everybody. Mg ether. Wait a minute. Where was Br? It should be Br here, na? Br to I forgot only. Huh. After that, they are saying that you are adding Mg ether. Now, bacha, we know that whenever you have Rx, you are adding Mg there, so it will be MgX. Grignard reagent will be formed, right? So basically, after this, what we will do, once you are adding Mg ether, that means you just need to copy paste this whole thing here, right? It will be this benzene, right? Then you will have this structure here, right? Okay, O bond, right? This thing. Here it will be MgBr here. It will be MgBr here. Okay, this thing will be formed, right? That means we have formed a very complex Grignard reagent. A very complex Grignard. Beta, these are the questions that they will ask you, right? These are the kind of questions from till here also they can ask you. Direct copy paste question can be asked. Very, very interesting question can be formed out of this, okay? If you're able to solve these kind of questions, I can guarantee you will pass organic chemistry with full marks, right? Now, here they are saying that you are adding CH2 double bond O ether. That means you have to do the Grignard reagent reaction here. Now, students, how the Grignard reagent react? Anybody in the comment section? Anybody in the comment section? Beta, are you also trying to solve it yourself, or you're just looking at me? That ma'am is solving. Or you are understanding, but you're not solving, but you are understanding everything here. What you are doing? Let me just... Now, after this, they are saying that you have added... They have written CH2 double bond O. We will write CHC double bond OH. Basically, this thing they are saying that you have added. Now, same thing I'll do. Mg is electropositive. The carbon next to it will be electronegative. This will be electropositive. This is electronegative. This is electropositive. That means this carbon here is going to attack on this one. So which thing will be formed? It a very, very important thing here I am writing, right? Firstly, though, you just make this carbon here, right? To this carbon, you will have the attachment of benzene. You will have the attachment of this benzene, right? Okay, or you can just write the benzene here, or electrons will jump here, no? So it will be O negative. So you can just write it like this. Okay, you can just write it like this. This will be... Okay, let us try to solve it. 1, it will jump here. So you will have the formation of C. This will be C. To this carbon, you have attached this. This carbon, you have attached this thing. What I am doing here? To this carbon that I have written here, I'll just write this carbon by green pen. Okay, this I am writing by green pen. To this carbon, you have attached this thing, or I will write this by yellow pen only, right? Okay. To this carbon, you have attached this particular carbon, okay? That you have attached, the whole part I have attached. This carbon had 2 hydrogens here. It had 1 O negative also. After hydrolysis, it will be MgBr. After hydrolysis, better firstly tell me, are you able to understand this thing? Are you able to understand this thing? How this thing is formed? How this is formed? How this is formed? Are you able to understand that or not? Are you guys able to understand how this is formed? After that, you have the formation of OH here. That means, can I write it like this? CH2OH. Can I just write it like CH2OH? For more clarity, can I just write it as CH2OH? Is this the right thing to do? Everybody, is this the right thing to write here? Right? Understood? Understood? Very good, very good, very good. Mark the carbon as 14. I'll just mark a dot here. Okay, I'll just mark a dot here where the attachment I have done. This blue dot is attachment, so that after the notes, when you're going through the notes also, you can understand that what I have done here. Okay, now, beta, one more thing, please, these 2-3 flowcharts, na, even after the class, try to do it yourself, maybe next Sunday. Okay, coming Sunday, try to do this yourself. Okay, it's okay that you are watching me right now, you are understanding it, but when you do the revision before the exam, at least one time solve these flowcharts yourself, self-study. Okay, that is my advice to you, right? Okay, now, beta, what carbon 14? Beta, no carbon, no carbon 14, there is no role of carbon 14, nothing here. What is the role of carbon? Simple, all carbon are normal only. There is no carbon 14 here. Simply, I have just written carbon. I'm just telling you that this is positive, this is negative. Attack is happening from this carbon to this carbon. That is why I have put blue dot over here. Right? There is no carbon 14. Ma'am, why carbon 14, ma'am? Is it given? No carbon 14, beta. No carbon. I have not even talked about any carbon 14. Right? Okay, no carbon 14. All are carbon 12, simple only. Right? This is negative, so it is going to attack here. That is why this bond is getting formed here that I am showing here. Right? Okay? Understood? Chalo. Beta, shall I move ahead or not? Shall I move ahead or not? Chal. Now, then you have NH4. Beta, dekho. When you have NH4Cl, na, this is the same thing. Let me just write it here. Basically, it was CHHOMGBr. This thing was formed here. After adding NH4Cl, what will happen? This will get converted to OH. OMGBr will get converted to, just like hydrolysis, no? It's the same thing, right? Okay, this will get converted to CH2OH. Okay, now next is, we have done this also we have done. After that, you are adding PCC. Now, what is PCC? Anybody in the comment section, what is PCC? Anybody in the comment section? PCC, pyridinium chlorochromate. Pyridinium is basically, pyridinium chlorochromate is a very good oxidizing agent, but it's actually not a very good, I would say it is a mild oxidizing agent. It is going to convert CH to OH only to, it is not going to convert it into aldehyde, to convert it into carboxylic acid, either to aldehyde or ketone, right? So what it will do now, what it is going to do now, I'm just going to write it here, right? Okay, let me just copy paste this thing and we will see next, some next reactions. Okay, now beta, what we are going to do here, this is the compound that we have here. I am using pyridinium chlorochromate, right? PCC I am using here. What will happen now? What will happen now? Here, what will happen? This will be converted to C, double bond O, and this is H. Okay, so this is converted to CHO. So I'll just write it here, CHO, right? And this is 1O, this thing. Okay, understood? Yes, beta, understood or not? Huh. NH4Cl here, basically it is going to convert OMGBr to OH, right? Just like hydrolysis, right? Okay, chal. Now, next students, next. Next is, okay, where is this PCC? This also we have done. Beta, don't spam in the comment section. Now, what will happen here? What will happen here? The class is going really good, right? Okay, why to do all these things? I can't see any Siraj here. So once I see, I'll see. Okay. You can just name the one Siraj. I can't see any Siraj right now in the comment section. Once I'll see, na, then I'll block. Okay. Chal. Now, here you have Me2. Basically, beta, this is Me2CHLI. This is THC. Okay. Me2CHLI. This is, I'll just give you one hint here. This is basically Core's house synthesis. This is Gilman's reagent, right? Okay. This is Core's house R2. Basically, what we are doing here now, it's just like Grignard reagent. Okay, it's just like Grignard reagent. What we are going to do here. Okay, I'll just write it Me2CHLI. Me2CHLI. Okay, Me2CHLI. Right. how it is going to behave. How it is going to behave. Okay, students? Okay. Just let me just show this to you. CH, this is double bond O. Okay, so I'll just write it like this. Double bond O, this is H. So what is going to happen here? We know that this is positive, this is negative, right? This is just like Grignard reagent. It is same as Grignard reagent. Okay, it is same as Grignard reagent. Okay, yes. It's new. It's new, ma'am. है ना? It's new. It is same as Grignard reagent. Same thing it will do. Same ditto copy paste. Okay. So this is positive. This is negative. Right? This is partially negative. This is partially positive because metals are always electropositive as compared to this. Right? Now here what will happen? We know that this is partially negative. This is partially positive. Right? Now students, this negative is going to attack on this positive here. And what you will have? You will have the generation of benzene is as it is. This whole thing is as it is here. This whole thing is as it is. Right? But here, things will be different. This carbon, we know that because it has attacked here, electrons will shift here. Hence, you will have CH and here you will have O negative. And here you will have the attack of CH here. So it will be C, this is CH3, 2-methyl na, CH3. Okay, and we know that here this is CH, so it will be one hydrogen here as well. So here it will be CH and this will also be CH. Basically this thing. Okay, got it? It is same as Grignard reagent. It is same as Grignard reagent. Got it or not? Yes, everybody. It is same as Grignard reagent. What worst thing, Rathi? What you're talking about, beta? Right? So there we used to attach MgBr. Here we are attaching Li. Right? Okay. So this thing is formed here. After that, what we are doing? After that, guys, what we are doing? I'm just gonna write it like this. After that, what we are doing? After that, after this, I am adding NH4Cl again. So NH4Cl is going to replace this metal with hydrogen. Okay. So NH4Cl is going to provide hydrogen here. It is going to replace this thing with hydrogen. So I'm going to write it in a better way because this looks very, very complex. So I'm going to write it like this. This is OO. And here it is on the para position. It is one carbon which is linked to one CH3 which is double bonded here. And here it is OH. Got it? What I wrote here. C, 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 CH3, 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 CH3. Okay? Right? Okay. Got it? Okay, bacha, got it or not? Now this is also done. That means till now we have covered, beta, don't spoil my hard work. All the students who are actually here to study, please don't spoil my hard work by indulging in all these things, okay? Now this is also done, this is also done. After that, they are again saying we will oxidize it by using mild oxidizing agent. Now again you need to oxidize it, guys. Oof, oof, oof. Again you need to oxidize. This is such a big question it is. Right? Again oxidize it, guys. Again oxidize it. Shabash. Everybody. Oxidize. Simply convert this thing into double bond O. So this is 1, 2, 3, 4 and this is double bond O. Isn't it? This is double bond O. This OH is converted to double bond O. This is your PCC. That is a good oxidizing agent. That is a very good oxidizing agent. This also we have completed. This also completed. This also completed. This is mild oxidizing agent. Right? Okay. After that, again we are adding PHMgBr, guys. Again we are adding PHMgBr. Oof. Again we are adding pH MgBr. Now though you are pro in this, isn't it? Too much confusion, ma'am. Too much confusion, right? Chalo. Now, okay, Rathi, got it. Got it. He is messages and deleting. Fattu. Chalo. Now, bacha, what we are going to do here? pH. This is partially positive. This is partially negative. It is partially negative. It is partially positive. So, this negative is going to attack over here. Electrons are going to jump here. Right? Okay. Shall we do this? Hana, will you do this along with me? Will you do this along with me? Everyone, right? Everyone. Beta, this time to nobody is there, na? This time to nobody is there. You guys, please focus here, na? Please focus here. Please, na? Don't do this. Don't do this to your ma'am, right? Okay, please focus here. Chalo. Now, here we are going to add it here. This will be benzene, right? This is, so I am just irritated of writing this again and again, guys. Again and again, I am writing the same structure. It's like some dawn with these big eyes is looking at me and, making me draw it again and again. So now, here this is your carbon, right? 1, this is 1, 2. Everything else is same. This is O negative. And we know that to this particular carbon, there is attack of pH here. So that means one pH is added here. And here you will have the attachment of MgBr positive. Isn't it? Isn't it? Everything else is same. The thing that we are going different, I have written it here. Right? Okay. Understood? Yes. Very good, very good. Dawn with big eyes. Irritating me. This dawn is literally, it's not on the head of benzene, it's on the head of me. Right? Why? Because I have to write it again and again and again and again. I have been writing it from 3 pages here. I am writing the same thing again. Okay. Now, after this, what we are going to do? Yes, beta. This is pH. pH also we have done. Then again NH4Cl, ma'am. Simple. And NH4Cl means just convert it into, you need to convert it into OH, right? Okay, so convert it into OH. This is NH4Cl. Just convert it into OH. How you are going to convert it into OH? Everybody, how you are going to convert it into OH? That will be converted like this. Again, the dawn is here. Dawn is here with 2. See, it's like I have a proper structure. 2 legs. Then it is having a cartoonic structure, 2 eyes. And then this is his head, right? He is like, as if he is kicking benzene. He is kicking benzene here. Now, benzene is having one group, which is this bond, these 2 methyl groups here. And this is one pH and this is one OH over here. This thing is what we will have. This thing is what we will have here. Chalo ji, next, ma'am. Oof, 15. Hydrolysis, beta, this is the same step, okay? After hydrolysis, we will get, wait a minute. This is basically, you have OH here, right? Okay. MgBr, which is this one. This is 15th, 16th, na? Just give me a second. This is 16th, right? Okay, just give me a second. Okay. This is hydrolysis. So, shall I draw one more page here? Yes, ma'am. You must, ma'am. You must, ma'am. Because ma'am has taken this big challenge of solving these big flow charts. So, ma'am has to do and erase and write and again ma'am has to do this. Chal. Now after this, you're going to do hydrolysis. Now, after hydrolysis, okay, on hydrolysis, what will happen? On hydrolysis, guys, what will happen, everybody? On hydrolysis, what will happen? Basically, these bonds will break, okay? This whole group will break. And here you will have the formation of double bond O, right? Okay, so here everything else will be same. Okay, everything else will be same. This will be same. 1, 2, and this is pH. This is OH. Everything else is same, but here you will have the formation of double bond O, and this is CH3. That means simple methyl I am going to write here. Right? Okay? Oof. Chalo, now next what we have? Next is till here, so we have solved it. After that, what we are solving? 16 also done. What is NaH? NaH is going to replace this O with Na, right? NaH, we are going to replace this O with Na, right? Okay, so everything else is same. Here, we will replace this O, you can just write it like this. Ketone is formed here. This is, you have 1, 2. This is pH and this is ONA, right? This is formed here, right? Negative, positive, you can write negative, positive, right? After this, what we are doing? Little things you are gaining out of this. 17. PHCH2Br. Okay, PHCH2Br. Guys, after that, what we are going to do? Everybody, PHCH2Br. PHCH2Br. Right? So it's again negative, positive will occur here. Right? Okay. Again negative, positive. Ma'am, please explain what beta? What? Nothing but simple. है ना? Here you have PH2, 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 PHCH2Br, right? So again, this is positive, negative. Again, positive, negative. This is positive, this is negative. It is going to attack here, and what you will have? And what you will have? This is benzene. This is double bond O, CH3. This is 1, 2, 3, 4. This is PH. To this positive, you will replace it with, this is O, CH2PH. CH2PH. Okay? OCH2PH. Okay. Okay, students. Okay, students. Right? Okay. Yes, everybody. Yes, everybody. Chalo. Now, this is also done. Wait a minute. 17th we have formed. 18th we have formed. Na? 18th we have formed. After that, we are adding NaBH4. Now, guys, what is NaBH4? NaBH4 is a reducing agent. It is a oxidizing agent. What kind of agent this is? NaBH4. NaBH4 is what kind of reagent? Reducing. NaBr will be released. Very good, very good. Now, NaBH4 is what kind of reagent? NaBH4 is a sodium borohydride. Yeah? Sodium borohydride is what kind of reagent? Reducing or oxidizing? Reducing agent. Hai na? It is reducing agent. It is going to not reduce. This is ROR. So it is not going to do anything with this ether, but it is going to reduce this ketonic to OH. So it will be OH over here, and here it will be 1, 2, 3, 4. This is PH here, and this is O, CH2PH. Okay. Oof. Next is next. Till here, how many? This is 19th also done. Acha, what is Al2O3? This I need to see how many of you actually remember what is Al2O3. Al2O3 is what kind of reagent? Anybody in the comment section? Then MCPBO also. PMGBR, chalo, one by one we will see. First you tell me Al2O3 is what kind of reagent, right? Okay. Al2O3, let me see in the comment section how many of you can answer this. Al2O3 is what kind of reagent, guys? Al2O3 is what kind of reagent, guys? Waiting for your answers, everybody. Al2O3, I can see. Yeah, that though you know, amphoteric oxide, shabash, very good. But yes, it is amphoteric oxide, but it is a dehydrating reagent, okay? It is a dehydrating reagent, just like H3PO4, just like H2SO4, P2O5, right? And Al2O3, all these are dehydrating reagents only. So it is going to take out water from here. It is going to take out water from here, and hence you will have the formation of, which thing? And hence, beta, you will have the formation of Al2O3. This is going to be, I'm just going to write it here. Right, next to I will write on the next page. This is OH. Acha, dehydrating na. So we are going to take out, this is CH3, right? This is CH3 na. This is CH2. This is CH3. This is OH, right? Now you are going to take out water from here. So take out O negative from this side, H from this side. Then there will be one double bond over here. So answer will be, Beta, understood na how I did it? OH, this is for example CH2, this is H. So you just take out OH negative, H positive, double bond is shifted here. Right? So that is why it is going to be this bond over here, double bond here. Right? Okay. And this is 1, 2, 3, 4, and this is OH. Okay, that is going to be the answer, right? Not the answer. We still have 2 reagents left. After this, you have completed 20th also. Now 3 answers more. MCPBA. Now anybody in the comment section, what is this MCPBA? Very interesting. MCPBA. Very, very important. Very important reagent. MCPBA. I'll give you one hint. It will act on the double bond. Okay? Higher temperature always favors elimination. Very good. Which thing is formed? MCPBA, transhydroxylation. So it is going to form epoxide here, right? MCPBA, right? MCPBA. What it is going to do? Everybody in the comment section. Ma'am, break. What to break? What to break? Tell me. Hana? Chemistry teaches you which thing? That old bonds will break and new bonds will form. Hana? This is chemistry, guys. This is life. This is life. From here we started from a very innocent reagent like this. Right? We started from a very, very innocent reagent like CHCl3. From there, we have this bond. We have this big compound, right? Okay. Which is this epoxide. Very good. This bond will break here. This bond will break. This double bond will break. Here one bond will break. You will have the formation of this kind of epoxide. So it will be this thing. It will be one double bond O here. Right? This double bond will break. You will have the formation of one O here. Like this. Okay. Now, everything else is same only. So, this will be 1, 2, 3, 4, 5. Chal. Okay, done. Guys, are you getting tired? Are you getting tired? Do you think, oh my God, ma'am, what we have done just now? Okay. Now, this is also done. After that, what we have? Beta, this is, so now again it is PHMGBr, again NH4 scale. Last time we are doing Grignard reagent here. Chalo, shabash. Everybody, let's do this together. Okay, let's do this together. Beta, escape velocity. I am not a physics teacher. Yeah, talk to Shreya sir about it. Okay? You're asking me physics questions here. Hmm? Sure. Now, let me just write it somewhere here. And this is the final reaction of this flow chart, right? Next flow chart is not that, lengthy, but it has new reagents, right? This particular flow chart was a bit lengthy, okay, because it was having all the reactions. It was not a simple reaction, okay, replace OH, okay, replace Cl. It was not a simple reactions. Everywhere we were like, we have to draw things here, right? Now you're again doing PHMGBr, PHMGBr, right? This is PHMGBr, beta. This is basically positive. This is negative. Here, this is partially negative. This is partially positive. So we know that it will attack on this particular carbon and this particular electrons will jump here. Okay. Now, here things will be different. You will have this benzene ring over here. Okay. This is this bond, ma'am. Everything else is beta same. Okay. You don't need to worry about that. Everything else is same only. Okay. This is this bond. This is one CH3, one CH3, one pH. This is OH. Oof. Now, I'll just draw it here because beta, I'm not that much tall now. So now I am going to draw some new compounds. This is one C over here. Now this is one O, right? Okay, this is, I'm just writing CH2. This is CH2. Here it is one O negative, right? And here it is. See, basically what is happening here, this bond will break. This carbon is attached to this oxygen also. This carbon is attached to this carbon also, right? So here it will be CH, not CH2, right? Okay, so it will be CH, right? That's why I have drawn CH. It will be now here, it will be C. This carbon is attached to this phenyl, right? So it will be CH to this phenyl. We know that here it will be MgBr positive. Bacha, now tell me, is that thing clear to everyone how I drew this thing? By simple one thing, Grignard reagent, I was able to draw this thing. Yes, students, are you able to understand this or not? Are you guys able to understand this or not? Yes, everybody. Now, after adding NH4Cl, this is converted to, this is benzene, right? Here it is 1. It is basically, you can just draw it like this, pH, OH, this is 1, 2, 3. I'm just trying to draw a more sophisticated diagram here. This carbon, I'll write it like this, 1 ethyl and 1 pH, C, then pH, and this is nothing but this is OH. Okay, and this is your 23rd compound that you have formed here, right? This is the 23rd compound that you have formed here, right? Okay. Yes, everybody. Yes, everybody. Okay. Okay. Wait a minute. Wait a minute, guys. Just give me a second. I think there is little mistake in writing. CH2, CH2. Wait a minute. This will be CH2. Hana? When we are breaking this, this should be also be C. Wait a minute. Why I have changed this? Beta, this will not be changed. By mistake, I have changed this. Okay. This will be CH2PH only. This will be CH2PH only. Okay. This will not be changed. Here also it is CH2PH only. Okay. CH2PH. Here also it is CH2PH. CH2PH. Okay. Here also it is CH2PH. Okay. OCH2PH. Okay. Dramatic, isn't it? Yes, everyone. Finally, OH is formed. Finally, we have completed this flow chart, right? Okay, finally, we have completed this flow chart. So, this is basically the answers you can see here. Here, the direct answers are written. I have explained to you also how this will happen. So, instead of that, you can just go through this thing, right? Okay, you can just go through this thing. One, first page, it is just going on, okay? 2, 3, 4, and then 5 page. 5 page conversions we have done here, right? Okay, 5 page conversions we have done here. Ma'am, that epoxide only explain, ma'am. Epoxide, beta, where it was formed? Wait a minute. Here, okay? Here it is formed. So, beta, double bond epoxide is basically when double bond will break, pi bond will break here, and you will have the formation of this thing. This is epoxide formation. Okay, so MCPBA is having a double bond, it is having a peroxide linkage of O and O, that is why it is there. Right, okay. Beta, break to I can't give you today, na? Break nahi, one more flowchart and some questions. After that, you will get free only. Right? Why I'm not giving you the break? The reason is I don't want to waste your time. Right? Because just one thing we are left with. Okay? Hi, everyone is asking for break. Why? Why you guys are asking? Tired? My head is gone. Is it? Break bonds. Ma'am, break. Acha. Okay. I was like, why these, everyone is asking about break. Yes. We don't break hearts, we break bonds. Okay. We are chemistry people. We don't break hearts. Right? We break bonds only. Right? We also don't give break. We also don't ask for break. Okay. Chal. This is done, beta. Now, do you want to solve one more flowchart or do you want to do some questions? I would like to solve this flowchart. It's not a very big flowchart. We have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 reactions. Okay. Right. Okay. Got it? Yes. Chalo. Done. Shall we start? Shall we start? Shall we start? Yes, everybody. Firstly, let us take deep breath in. Chalo. Let us restart. Okay. So let's take some break. Na? In between, you can take break in between the class also. You can just relax. Okay. Just relax. And now, are we ready for the next class, next flow chart? Are we ready? Are we ready? Yes, chalo. Okay. This is the next flowchart. Oh, by mistake, I have given you the answer as well. Now, beta, here it is simple reagents. Only 1, 2 questions you will find tough. Otherwise, so it will have simple. The last flowchart took us so much time because there was usage of Grignard reagent again and again. Right? If you are able to understand that, now, one student is asking for Grignard reagent, beta, see, pause this video, go and watch that previous flowchart again. Grignard reagent will be clear. Right? Okay. Now, CH3, ma'am, Cl2H mu, ma'am, please add. Now tell me, beta, in the comment section, shabash. In the comment section, ma'am, G is wrong. Where, beta? Where G? Okay, let me see, Madhu. G. A, B, C. Beta, G, that means you're talking, where G? Here G? Where G? Madhu, what you're talking about? Chal. Now, chlorination will occur here. So, what will happen? This will be, I'll just write it here. I'm just going to write it on the next page only. So, here it is CH3. You are adding Cl2H mu. Cl2H mu. What is going to be formed? You will have the formation of CH3, CH2Cl. Right? This thing will be formed. After that, you are adding alcoholic KOH. Now, students, what is the work of alcoholic KOH? Alcoholic KOH, guys, everybody in the comment section. Everybody in the comment section, what is the work of alcoholic KOH? Yes, everybody, alcoholic KOH? Haan. Alcoholic KOH is going to take out this chlorine and hydrogen from here, and you will have the formation of CH2, or you can just write it like this, CH2 and CH2. After that, you are again adding, this is done, this is not done, then you are adding Br2CCl4. 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 Now, this we have done before as well. First few reactions will be same. CH2, CH2. Here you will add Br here. You will add Br here. Okay, ma'am. Next, ma'am. Next, ma'am. Next, ma'am. This is also done. NaNH2 and heat it. NaNH2 and heat it, guys. NaNH2, add NaNH2 and heat it. What will happen? Everybody, add NaNH2 and you need to heat it. Which thing will be formed? Yes, guys, which thing will be formed here? Everybody, right? Okay. Pankaj Bishnoi, it's the problem is that this channel is English channel, hai na? So I'll talk in on that language only, which is the name of the channel. If it would have been a Tamil channel, I would speak in Tamil. If it would have been a Hindi channel, I would speak in Hindi. Okay. Now, here it is NaNH2. Right. So here what will happen? Dehydrohalogenation, and hence you will have the formation of CH triple bond CH. Alkyne is formed. Right. Okay. Alkyne ethyne is formed. Very good. Right. Red hot tube. Red hot tube. After that, you have red hot tube here. Red hot tube. Now, aromatization will occur and you will have the formation of benzene here. You will have the formation of benzene here. Right? Benzene is formed. After that, you have Br2Fe. Now, things are changing. Br2Fe means you are doing the bromination firstly. You are doing the bromination here. So, when you do the bromination here, which thing will be formed? When you do the bromination first, you are adding Br2. Then you are adding Fe here, right? Here what will happen? This is benzene. Bromine is attached here, right? After that, beta, after that what you're going to do? Everybody. Then they are saying that nitration. Then there is nitrating mixture. Now you have to tell me whether bromobenzene is. Then beta they are saying that after this you are adding nitration. That means nitrating mixture you are adding. Nitrating mixture, guys. Nitrating mixture. What is nitrating mixture? That means NO2 will be generated. Right? Nitrating mixture means HNO3 plus H2SO4 you have added. Now tell me one thing. Is bromobenzene ortho-para directing or meta-directing? Is bromobenzene ortho-para directing or it is meta-directing? Yes, everybody. Is bromobenzene ortho-para or meta? Ortho-para or meta? It is, because we have lone pair over it, it will show plus M, so it will be ortho-para directing. Very good. Right, so here it is going to be, this is benzene, and on the ortho position and para position you will have NO2. We know that para is more stable, so that is why you will have NO2 over here. Right, so para will be formed here. Para will be formed here. Right, this thing will be formed. Acha, after this again you have to add something here. Now the thing is going to be very, very interesting. Till here though it was simple. Now add KCN here. Now they are asking you to add KCN here. You have to add KCN, guys. You have to add KCN here. Okay? Now you also have to add KCN here. Everyone add KCN. Right? Okay. You have to add KCN here. This is basically, you're adding KCN directly, right? So when you add KCN, what exactly happens? Have you seen that reaction? Rx plus KCN it gives RCN. Do you remember that reaction? Do you remember that reaction, guys? Do you remember that reaction? Ma'am, Br replaces. Very good. है ना? KBr won't eliminate. Where KBr? हाँ, definitely KBr will eliminate. Very good. Very good. KBr will eliminate here. Right? So here what will happen? You will have the formation of, beta, we are not discussing stereochemistry, okay? So here it is CN and this is NO2. That is formed. After that, they are saying, now I am going to not make a mess here, right? So what I'll do, I will use the next page here. I'll use the next page, right? Okay. I'll use the next page where I'm going to use this compound that I drew last, right? After that, let us see what are the reagents that we are adding here, right? Let us see what are the reagents that you are adding here. The reagents that we are adding here is, this thing is formed, this is formed, MEMGBr and hydrolysis. Can you see this is Grignard reagent, right? Okay. Ma'am, NO2 group present, so there will be the reaction. Yes. So there will be the reaction. Yes, beta, there will be that reaction. That reaction will happen, will occur, Manish. Okay? Yes. Now, after that, you have here what you have. This is MEMGBr. This is basically CH3MGBr. Right? After that, they're also doing the hydrolysis. Right? So what we are going to do? This is partially negative. Now, the one who was asking me about Grignard reagent, you can watch this now. Okay? Grignard reagent is, this is positive part, this is negative part. We know that on this, Grignard reagent will behave in a little different manner. Right? I'll tell you the reason behind that. Because here, different manner means it will do the same thing but on some other carbon. Here it will not be carbonyl, rather it will be this cyanocarbon, right? So it will be partially negative, this is partially positive. That means this negative is going to attack here and the electrons are going to jump here, right? Now guys, here what they are saying, here they are saying that after this you have the formation of I, right? Okay, that means NH2, okay, that will be formed here, right? Okay, chalo. Now let us do this. Firstly, one by one I'll solve this, right? Okay, so this is benzene. Here you have NO2, right? This is a C. This is, we know that double bond N, right? Okay, this will be MgBr something, right? Okay, positive, right? Acha, here you will have the attachment of CH3, right? After hydrolysis, this will get converted to oxygen, right? Okay, so that means I can just write it here that it is C double bond O CH3, right? Okay, this thing will be formed here, isn't it? This thing will be formed here. Got it? Okay, yes. Okay guys, understood? Now, bacha, is that clear to everybody? Is this thing clear to everybody? COCH3. Now what we are going to do? Again, we are going to, this is I, NH2OH. Do you remember one more reaction? I'll tell you that reaction, right? One more reaction, very, very interesting, very, very important, right? That reaction is, if you have C double bond O, this is R dash, okay? And you are going to react this with NH2 and this is Z. This O and H will be eliminated and hence you will have the formation of this, they both will link together and you will have this, you will have the formation of this thing. Same thing will happen here because now you are reacting this with NH4OH, right? Okay. NH2OH, why I'm writing NH4OH. This is NH2OH, right? Okay. Right. Now, after this, you'll have two things, right? Okay. Basically, guys, what will happen here now? Because this is NH2OH. Basically, you had here C double bond O. This is NH2OH. This is NH2OH. Here, this will be eliminated and hence you will have the formation of N-oxime. That is, this thing will be formed. Because this is formed from a ketone, that means a keto-oxime will be formed. Okay? Very good. Keto-oxime will be formed here. Right? So, we'll just form it, but because they have told, I don't know why my skin is like totally going red right now. Okay, so this beta here you will have the formation of, this is benzene, right? Okay, I'll just write it in some other way, right? Let me just write it like this. You'll have the formation of K and L, na? So here it will be, this is carbon, right? This is double bond, this is N. To this you have the attachment of CH3 and one is benzene. One is benzene that you have. Like if you have benzene on the para position, this is 1, 2, 3, 4. Wait a minute. I'll just write the benzene like this. Okay. Then NO2 will be present here. Right. Okay. Now, on one you will have lone pair. Right. On the other you will have NOH. That will be the first thing that will be formed. That is why I was telling you that this reaction is different. Okay. One is this one where you will have C double bond N. Here lone pair is downwards and OH is upwards. Right. Here it will be OH only. NOH. Right. OH. This is again benzene. Right. I'll just draw it like this. On the para position you have NO2. Right. Okay. And here you have CH3. Right. Okay guys. Understood this point or not? Everybody, is this point clear to all of you or not? Everybody, is this point clear to all of you or not? Is this point clear to all of you or not? Yes. Ma'am, it's just NOH. Yes, it's just NOH. Okay. So, beta, is that clear to everybody? Now, one by one, I'll do the reactions. Because see, I'll tell you one thing over here. Two things are given to us, that K and J are formed. Till here, we have formed everything. Now, there are different reactions of K that you will see here. Wait a second. Right? There are different reactions of K that you will see here. And there are specific reactions of this J that you will see here. J is following a different sequence. K is following a different sequence. So, firstly, we will solve with K. Okay, firstly, do you want to solve K first or A first? K first or J first? Yes, do you want to solve K first or J? K or J, K or J, K or J? Very good. Beckman rearrangement. Hanji, do you want to solve K or J? Beta, tell me, do you want to solve K or J? Same thing we will do, like same kind of reagents we will be using, right? But the product will be entirely different. Okay, so firstly I'll solve with K only. Firstly, let us solve. Chalo, it's totally your choice what you want to solve. KJ mix. Chalo, firstly let us solve J. Okay, firstly let us solve J. I'm solving J firstly. Now they are saying that with this particular thing, what you will have, right? What you will have, firstly they are saying that what you're going to use here, with the J, what you will have. With the J, what you will have, I'm just writing the J part here. So with J, firstly you have dilute H2SO4, right? So both, whenever you use dilute H2SO4 here, na, so it will show a very different reaction here, right? It will show a very different reaction, right? Anybody in the comment section? Hanji. Now, here what will happen? This benzene, right? And this is the para nitro, right? Then you will have this C, but this C will have the double bond, right? I'll just show you, right? This C will have the double bond here, right? Two kind of things will be formed. Basically, this is, if you talk about to this phenyl group, right? When lone pair is attached in the opposite direction, right? So here what will happen? This is CO, then it will be NH, right? Then it will be CH3, right? 1, 2, 3. Okay, so this thing will be formed, right? When you add dilute H2SO4 on this particular ketoxime. Okay, now, but chalo, firstly let us do solve this thing only. After that, this is the most important point. This is the most important point, right? After that, though, you use hydrolysis. Yes, everybody. After that, do hydrolysis, right? Do hydrolysis. In hydrolysis, what will happen? In hydrolysis, when you do the hydrolysis here what will happen? This whole part will be converted to OH. So it will be NH2. This is COOH, right? Okay, NH2COOH. After that, what you're doing? After that, what you're doing? Okay, this is done. This is done. Now, upon hydrolysis, wait a minute. If you have the formation of minute, acha, two compounds they are saying now. OH, CH3, NH2. Okay. So basically, if you talk about now, because they have asked you to form two compounds here, that's why we have to draw both the compounds. We have to also draw the byproduct here. So I'm drawing the byproduct here as well, right? We need to draw the byproduct also here, right? Basically, what is happening here? This bond will break. You will have OH negative attached here, and the hydrogen will be, H positive will be attached here. So you'll have the formation of CH3NH2. Okay, these two parts will be formed here, that is M and N. Got it? Got it? Yes, yes, everybody. Okay, now what we are doing, they are saying that this is a separate reaction. They are telling that to N you are adding NaNO2 diazotization after HCl. That means for alkyl, when you add NaNO2, right, and then you add HCl there, or you can just add water also, it doesn't matter, right? Even if you are simply adding NaNO2, even then, because it is not very stable, so that will form the same thing, that is CH3OH, right? Now, for this one, what they are saying, this also beta done, this also we have done. Okay, this reaction also done. Now, for M, they are giving you a different path. That is, you have to add NaOH-CaO. NaOH-CaO. Now, when you are adding NaOH-CaO, NaOH-CaO. Now, what is this reaction? NaOH-CaO. It is soda-lime decarboxylation reaction, right? Okay. Hanji students, right? Okay. Ma'am, E is benzene pakka. E beta, where it was drawn. Ha beta, it is in benzene pakka. You can see here, right? From this red hot tube, you will have the aromatization. Okay. Chal. Now, here it is soda-lime decarboxylation. Basically, carbon dioxide will be removed here, right? In soda-lime decarboxylation, you have the formation of RH or RR. RH or RR. Yes, everybody. RH or RR. Everyone, what you will have in the end? You'll have the formation of RH or RR. Hanji. You'll have the formation of RH or RR. RH, na? I jumbled the sequence. Okay, okay, okay. So which E you are talking about? Huh. So this is will be RH will be formed. So basically this is benzene, this is NH2, and here this is hydrogen because CO2 will be eliminated. So you'll have the formation of this nitrobenzene, right? Nitrobenzene will be formed. After the nitrobenzene, they are saying that you're using tin HCl. Now tin HCl is, wait a minute, why I have written NH2 here? I'm so sorry guys, my mistake guys, this should be NO2, right? It should be NO2, not, it will remain the same, na? It will remain NO2 only, right? Okay. After that, what I am doing here, I am adding, which thing here? I am adding tin HCl. Tin HCl. Tin HCl is nothing but it is reduction. That means this will be reduced to NH2, right? Okay. After that, what I'll have? This is also done. Then I am doing the diazotization and I get Q. Diazotization, guys. Diazotization. I'm just writing NaNO2 HCl. What I'll get? I'm just writing it like this. Okay. So you will get N2Cl positive negative. After that, you are doing H3PO2 heat. What is H3PO2 heat? When you add H3PO2 and you heat it, you will get the answer as benzene. Okay, the answer will be H3PO2 and you heat it, the answer will be benzene is formed. Benzene is formed in the end. Right? Okay. Benzene is formed in the end because that will be eliminated. You add CH3COH, you add ethanol, it will give you the same answer. Okay. Yes. Done, guys. Okay. Okay, bacha. Done or not? Yes, everybody. Yes, everybody. Chalo. Now, this is clear now. Now, I'll just draw it here. Right? And I'll draw this thing here. Right? Just copy paste this thing. And now we will see this particular reaction. Okay. What about this K that we have formed? Right? What about this K that we have formed? So it is going to give you, because this benzene and this is on the same side, right? So what will happen here? It will be benzene. This is NO2 group, right? Okay. This is NO2 group. After that, you will have the formation of, this is N, right? They will rearrange, na? So this will N, this is C double bond O, this is CH3, right? So that thing will be formed here, CH3, okay? So this thing will be formed here. That is why the answers are going to be different in both the cases, right? Okay. Very good, Jenny. Very good, very good. Jenny, that's great. That's really, really amazing. Right? Okay, chalo. Now here you also complete the hydrogens here. NH. And just write it here, NH. Right? Okay. Chalo. Now let us again start this. What about this K? You add dilute, you had this R. Then you hydrolyze it. Hydrolyze it, guys, what you will get? Hydrolyze it, what you will get? Again, break that bond, na? You just hydrolyze it. Now, I want you to solve it yourself also, right? Do the same thing as we have done before, right? Do the same thing as we have done before, right? Now, hydrolyze it, guys. Do the same thing. Break this bond, right? Attach OH negative here, H here. What you will have? You will have, this is benzene, right? This is NO2, right? And here you will have NH2, right? Here you will have plus, this will be CH3, C double bond O, OH. This is what you will have here, right? Okay, chal. After that, what they are saying here, that you have made, after this, you add this, you will have S and T. Oops, so sorry. Oye. You will have S and T, right? They are saying to T you are adding 10 HCl, to S you are doing SOCl2. So basically S is, my supposition is S should be this one. Okay, to S they are saying that add SOCl2, because there is no benefit of adding SOCl2 there, right? They are talking about this thing only, right? So here it is SOCl2, answer will be CH3 C double bond OCl. After adding SOCl2 here, this is also done, this is also done, this is also done. Then you add, acha, this is the not, है ना? This is not given, right? This by mistake wrong thing is written here, so I'm just erasing that. Till here, so everything is sorted. Now they are saying that from T add 10 HCl. To this T, they are saying that, okay, what I need to do, I'll just solve it here only, beta. I'll just solve it here only, right? Okay, because we need space also. This is SOCl2. Now here they are saying that add 10 HCl. 10 HCl. If you add 10 HCl, what you will get? This is benzene. Basically, NH2 will remain NH2 only, but this NO2 will get converted to NH2. Right? This thing you will get. And after that, they are saying that add NaNO2 HCl. Again, diazotization is happening. Right? NaNO2 and HCl. Again diazotization, that means again you have this benzene, right? This is N2Cl positive negative, this is N2Cl positive negative, right? Okay, after this they are saying that, acha, this to you tell me. Okay, last beta, it's your call, you tell me what we are going to do here. I'll just come only few times. Okay, cool. Acha, everybody, last thing you will tell me, on adding H3PO2 here, what will happen? On adding H3PO2 here, what will happen? Now let me see how many of you answer this. On adding this, what will happen? Yes, students, what will happen here? Everybody, yes, which thing will be formed? Very good. Ma'am, my last name is the product. Very nice way to answer. So answer will be very good. Answer will be benzene. Okay, benzene is going to be the answer. Okay, benzene is going to be the answer. Chalo. Very good, guys. Very good, very good. Very, very, very good. Okay. Now, that thing is clear, guys. Clear, clear, clear. Now, shall we do the questions? Shall we quickly do the questions here? Right? Acha, do you promise me that you will solve the chart that I'll give you? Do you promise me that? Do you promise me that, kids, that you will do the chart that I'll give you? Right? Okay. Yes. Beta, I have already done that. Yes, I've already done that, beta. Okay. Chal. Now, we have done almost everything. Now, we are going to solve some questions here. Beta, don't see this particular answer because that, oops, by mistake I deleted that. Okay, I'll just put the slides here. Don't see this particular answer because here the answer is wrong. Okay, so that's why I'm deleting this. You will get confused. Okay, chal. Now let us do some questions here. Okay, I want, now you will feel that, ma'am, questions, ma'am, such simple questions, ma'am, you have given us. Ma'am, it's so high level you have taught us and such simple questions you have given us, right? Okay, now, are you all ready for the answers? Are you all ready? Let us do that. Give me, very good, Jenny, very good, very good. Okay, now let us do the questions here. Okay, let us do that. Very, very simple, you will find. Now your brain will feel na ki okay, this is simple, I can do this in 10 seconds, right? Okay, yes everybody, bacha, yes everybody, yes, very good. Now the first question on your screen is identify compound Z in the following reaction sequence. If you're talking about the first reaction, what is this process called? What is this process called, guys? This is called Dow's process. That means the Cl will be replaced by OH here, right? Okay. Now, after that, you add HCl to it, right? You are adding HCl to it, right? HCl simply means initially it was ONA, right? Then you add HCl to it, it will become OH. Okay, nothing, just to confuse you. Okay, concentrated HNO3. That means concentrated means, I told you, on both ortho and para position there will be substitution. On both ortho and para positions there will be substitution. So answer will be A is the correct answer, ma'am. Okay, chalo. Next question, guys, on your screen, right? As you can see here, identify the major products A and B respectively in the following sets. Right, guys? Okay, everybody, tight. Okay, trinitration. Very good, very good. Now, identify the major product A and B respectively in the following set of reactivity, following set of reactions. Okay. First is they are saying that concentrated H2SO4. What is concentrated H2SO4? Ma'am, this is going to take out water, ma'am. Yes, that was picric acid. It is going to take out water, ma'am. How it will take out water? OH from here, H from this side. So double bond will be here. So it will be basically A is going to be this particular thing and this double bond here, right? That is going to be A, and there will be one CH3 over here. This can be A, this will not be A, right? Because we need to have Sedzef alkene. We need to have more highly alkylated alkene. This will not be A, this can be A. So either this can be A or this can be A. Right? You will say, ma'am, here to they have written here. Ma'am, you have written here, beta. If they eliminate from this beta position, then it will be this much. Both are same only. Both are symmetrical only. Okay. Now, CH3COCl and pyridine, it is going to do the acetylation. That means acetylation means you have CH3 here. For this hydrogen, you will have the replacement of COCH3 here. That means this thing will be formed, COCH3. This thing will be formed, COCH3, right? Here this is not possible, OCOCH3, that means fourth is the correct answer, right? D is the correct answer, guys. Yes, beta. Okay. Chalo. Next is the product C in the following sequence of reaction has. Okay. First is you are doing a very strong oxidation here. So whatever alkyl is present here, if it is not isopropyl, then it will be directly converted to COOH, right? Okay. Then definitely you are doing the hydrolysis, the same thing you are doing. After that, you are adding Br2 FeBr3. That means you are adding Br positive electrophile here. Electrophilic substitution you are doing. We know that this particular compound, it's like this. Can I just write it like this? It is connected to an atom which is doubly bondedly connected to another atom which is highly electronegative. That means I can say that this is showing minus M effect, right? Minus M effect means it will do meta substitution here. That means ortho meta. Over here you will have the meta product. Right now they are asking you has dash pi bonds. How many pi bonds it has? Beta pi bonds to 1, 2, 3, 4. 4 pi bonds it will have. Right? How many pi bonds? 4 pi bonds it will have. Ring deactivation group. Very good. Meta directing it is shabash. Very good, very good, very good. Right? Okay. Chalo. Next question is okay. Again, the same kind of question, but it has something different here. Right? Okay. The major product B formed in the following sequence. Now, I told you if you have KMNO4, right? very strong oxidizing agent. It will convert it directly to carboxylic acid, right? So A is carboxylic acid. After that, you are adding NO2 positive electrophile. This is meta directing. So it will be, electrophile will be present somewhat here, right? It is present over here. It is present over here, right? This is N. Now they are asking you the number of pi bonds. So I'll draw it like this: 1, 2, 3. Here also I'll draw it like this only. This is 1, 2, 3, because I need to calculate the pi bonds. How does NO2 look like? This is double bond O, right? This is O. This is negative because it is only one bond. This is 4 bonds. It was supposed, nitrogen was supposed to make 3 bonds. So when you get more marks than you deserve, than you expect, you will get happy now. So it was supposed to make only 3 bonds. It is making 4 bonds. So it is positive. It was supposed to make 2 bonds. Oxygen is always forming 2 bonds. But it is forming less bonds. It will be like shit. Something bad happened. You will be disappointed. So it is negative here. Now you just calculate the pi bonds. It is 1, 2, 3, 4 and 5. So number of pi bonds are, we have 5 pi bonds. Right? Okay. Yes, students. Simple. Okay, next is this one. C2H5Br. Right? Okay, C2H5Br. Now you need to tell me the answer for this one, guys. Answer for this one. Right? Okay. Chalo. C2H5Br with alcoholic QH, it will go with C2H5. This will be OH. Right? This done. After that, you will have Br2CCl4. Br2CCl4. Achha, this is alcoholic QH. So sorry. This is alcoholic QH, means you will have CH3. It will be something like this. CC. This is CH2Br. This is CH2. This is H. This will cause dehydrohalogenation. This will be eliminated. This will be eliminated. You will have a double bond here. Right, so this will be CH2 double bond CH. This is what I was telling you, that from these flow charts, you'll be able to answer these kind of sequence reactions that are given to you. Right, okay, some sequence is given to you, they're asking you the last product. Right, now here after this, you will add Br. That means this pi bond will break. You will add Br here, you will add Br here. Right, okay. Then they are saying that you add KCN in excess. That means this Br and this Br both are eliminated by this Cn, right? Then they are saying, I'll just write it here. This is basically CH2. No, it is CH2, CH2. This is Br, this is Br. This is CH2, CH2. This is Cn and this is Cn. Now you are doing the hydrolysis, right? Now you are doing the hydrolysis. After hydrolysis, both Cn will be replaced by COOH and this is COOH. And this is nothing but this is succinic acid. Okay, this is nothing but it is succinic acid. So answer is B is the correct answer. Okay, got it, guys? Yes, everybody. Bacha, if you are actually, you think that I have done a lot of hard work on this and you're actually enjoying this session, you think that this is giving benefit to you, then please like the session and also do comment. I see every day, I wait for your comments. Yesterday also there was this one comment that was GUD. What was that? Huh? I mean, really? Am I a nursery class student you are giving good to? Like, seriously, yeah. So disappointed I was. Right? So, yes. Now, is that clear, guys? Is that clear? Now, next question is, you have the product C below, that is mentioned below is. So, guys, if you talk about this thing, what is the product C? Everybody. Yes. The product C, basically, if you have alcohol, you have, this is, wait a minute. This is alcoholic. Okay, let me just write it correctly. This is aqueous. Okay, typing mistake it is. So I'll just write it here. This is aqueous. Okay. So now here what we are doing, We are just alcoholic KOH means we are eliminating Br and this Br and hydrogen from this side. So A is going to be CH3, CH double bond CH2. After that, you are adding Br here. After that, you are adding Br here. That means it is going to be CH3, CH2. You are simply adding Br. That means negative to less number of hydrogens. So Br over here and hydrogen over here. Now, after that, you are again replacing this, right? Because you're adding aqueous KOH. So it will be, okay, just give me a second. Let me just write it here. So it will be KOH aqueous. Then after that, it will be CH3, CHOH, CH3. So answer is going to be propane 2-ol. That is, D is going to be the correct answer. Right? Okay, guys. Chalo. Okay, next question on your screen. Everyone, are you able to see this or not? Everybody in the comment section, are you able to see this or not? Yes, students. Yes, students, everybody in the comment section. Yes. Now, students, as you can see here, identify A and B in the given chemical sequence. Right? This is the same question that we did in the sequence also, right? When we were doing the flow charts, right? So this is benzene, right? So this is N-hydride, right? N-hydride you will have here, right? 1 N-hydride you have here. I told you what will happen. What will happen here? Because of anhydrous AlCl3 here, it will break this bond here. It will break this bond here, right? There will be positive here, negative here. So what will happen? This is benzene. This is benzene. On this benzene, you will have the attack of this carbon with double bond O, then this carbon, then this carbon, then you will have double, then this carbon, this carbon. Now this is C double bond O, OH. This thing will be formed in the first place. This plus this, okay? I'm just going to write it the same way, right? Okay. So it will be added and you will have the formation of this thing. Do you remember? We have already done this, right? Okay. After that, they are saying that you add zinc amalgam. Zinc amalgam, that means Clemenzin reduction. Zinc amalgam means Clemenzin reduction you do. Here what you will do, this is benzene here, this is benzene here, this is CH2, 1, 2, CO, or you can just write it as C double bond O, OH. After that, they are saying that, this is also done, add H positive here, right? So you have to add H positive, that means basically acid you are adding here. So whenever you are adding an acid, dehydration will occur. So this is 1 hydrogen, it will be taken out, OH negative will be taken out, and these two will join together, and hence you will have the formation of, 1, da-da-da, 1, 2, 3, 4, this and double bond. Okay, that thing will be formed here. Okay, understood? So here what you will have, they are saying what is A? What is A and B? Acha, this to they have given you only. So sorry. Okay, so they are asking you A and B. A and B means this thing they are asking you CO, COH. You have to have CO, then you will have COH. That means this thing you will have. This is A, right? So answer will be 3 only, right? What is B? This will be reduced. This will be CH2, then COH. That means answer is 3rd is the correct answer. Okay? C is the correct answer. Okay? Got it? Everybody? Everybody in the comment section, bacha, is that clear to all of you? I think now though we have started with this one. Now, this is the homework that I am giving you. You need to tell me the reagents here, right? You need to tell me the reagents here, guys, right? Okay, I'll just eliminate few things from here, right? Okay, just give me a second. Wait a minute. This is also done. Okay. SO3. Okay. ONO, OH. Then you have NO2, N2, this. Okay, done. Now, I'm giving you this particular homework, right? I'll be writing A, B, C, D, everything here. You need to tell me in the comment section, guys. Okay, only then I'll tell you the answer in the next class. If I can see that you are actually doing the homework, okay? So, let us see if this is A, this is B, this is C. Okay, so let us just write it like this. This is A, this is B. Okay, this is C, D, E, and this is F, G, H, I. Okay, so you need to solve this particular flow chart. You can take a screenshot of this over here. Top not visible. Is that not okay? Is that not visible? Wait a minute. Now is it visible, guys? Now is it visible? Let me just see it if it is visible now. Right now, is it visible? Bacha, don't tell it here. Don't do cheating. No cheating. Okay? Now that is visible, right? This is NO2. Okay? Yes. I'll just do one more thing. Okay, now you can see. Now I think that would be better. Right? Just erase this thing. F, G, H. This is I. Right? A, B, C, D, E. Okay? So all this chart you have to take a screenshot of this. Okay? Thank you. Chalo. Take a screenshot of this, beta. Take a screenshot. Done. Okay. I think now that it's completely visible, right? Okay. Ma'am, smile. Yeah. You want to take the screenshot along with me? Then yes. Now I think this is the perfect place. You can take the screenshot now. Right? Okay. Chalo. Screenshot taken, ma'am. Perfect, perfect, perfect. I have already smiled, yeah. Already smiled. Right? Now. Okay, so guys, that's it for today. And one more thing that, guys, just give me a second. Let me just show you the offer, right? Because this offer is going on right now, right? Just give me a second. Okay. Just give me a second. Let me just show you the offer that you all want to know, right? Okay. So, here, beta, on this Christmas festival, from 24th December to 1st of January, offer is going on, right? So, it is basically on so many things right now. So, according to what you want, if you want to purchase the course, right, we have 3 courses basically, that is Prime Crash Course, or you can go for Pro Crash Course, or you can go for Pro Plus Crash Course, right? So, all these are in sale. Our Prime Crash Course is available at 999 only for JEE Mains. If you talk about Pro Crash Course, where you will get in-class doubt solving, practice test, printed study material, and 24/7 instant one-on-one doubt solving, that is available at 499, around 50% discount it is, right? If you talk about Pro Plus Crash Course, then you will also get personal academic mentor for personalized guidance, right? And in-class doubt solving, practice test every Sunday, printed JEE crash books delivered at home, that is for 12,999. Okay, so all these courses are available for you right now from 24th to 1st of Jan. That is available, that discount is available to you. Now, if you're looking for the the booklet. Okay, you can see the test series. Now focus JEE Means and Advanced Test Series 2025, that is available at 1333. Again, 50% off is there. 20 full length test. You will get 10 full length test for JEE Advanced. You will get, right, and subject specific. Just give me a minute. Just give me a minute. I think drink some water. Eventually, I'm a girl now, so I get excited when I see sales. Okay, so subject specific mock test to stimulate real exam conditions, right? And if you want to see online test series at your home, right, so you will get it at 1666, right? Sorry, this is not a test series. This is basically all in one test series for 2025, where you will get 140 plus mock test, right? Here you are getting 20 full length plus 10 full length for advance, and here you are getting 140 plus mock test, right? Now next is JEE Mains plus JEE Mains Crash plus Focus TNT test series, that is available at 1799, right? And you know, if you want to avail the offer, you can avail it right now, right? Because price hike is going to be from 1st January, right? Then you will see that, ma'am, why didn't you tell us, right? Even your ma'am is doing a lot of shopping, right? Okay, why? Because sale is going on everywhere. So that's it. That's all I want to tell you, that avail this offer when some sale is going on now, so that benefits you only, right? You will purchase this after 2 months. What will happen? You will lose the time also to solve the questions. Now you have all the time in the world, right? You can solve these questions, practice for your JEE Advance as well right now only, right? So the biggest sale is going on right now. That's why I'm telling you that purchase this offer. That's why we have given you enough time to think upon that, so that it's not like one day sale. It's proper 5-6 days we have given you, so that you can think about it and then purchase it. Yes, chalo. Okay then, beta. Bye bye. Take care. See you all in the next class. And I am waiting for your comments in the comment section, where you are going to solve this particular flow chart. This is what I am waiting for. Okay, I am waiting for you to solve this particular flow chart, and also how you like this session and what you want me to do for physical chemistry. Like, what is the problem that you're facing in physical chemistry? Okay then, bye bye. Take care. See you all in the next class. Bye bye. Ma'am, what is your Telegram account? Definitely, yeah, I have the Telegram account. I'll just write it here. That is t.me/Diksha Kaushal Chemistry. Diksha Kaushal Chemistry. Okay? Diksha Kaushal Chemistry. That is the Telegram account that I have. You can go and follow that. Okay? Yes. Okay, then problem solving. Beta, whatever you have for, whatever the queries that you have for physical chemistry that you want me to do, what are the problems that you're facing, so you can write it down in the comment section, so that I can see your comments after this, right? Okay, bye bye, take care, see you all in the next class, and good night, take care and study, because this is your time to give your 100%, do the hard work and prove yourself. Bye bye, take care.